Hello everybody. Hello, hello. Am I audible, visible? Please let me know. Hello, 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 hello. Yes, 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 audible. Yes. So, இன்னைக்கு என்னடா chapter? Which chapter we are discussing today? Everybody. Yes, guys, start with putting some hearts. Everybody with fire. At least Kritika is for me, right? Kritika knows my mind. She can read. I know you are a mind reader, right? So actually வந்து இந்த கிளாஸ் ஸ்டார்ட் பண்ணுறதுக்கு முன்னாடி ஐ ஃபெல்ட் லைக் ஓகே இப்போ வந்து கொஞ்சம் ஹார்ட்ஸ் கரைச்சேன் ஹார்ட்ஸ் கம்மி ஸோ இன்றைக்கி எனக்கே தெரியலடா தெர் இஸ் சம்திங் ஹேப்பனிங் இன் த ஹோல் ஸ்டுடியோ இட் வாஸ் கெட்டிங் டூ வாட் டு சே slow. I don't know the reason. So anyway, after getting a lot of hearts, I think everything is getting normal. Yes, thank you Gautam, thank you Kritika. Yes Diya, yes Siva. Okay. So yes, Durga, how are you? Okay, Harish, Hajar. No breakdown will happen, no ma'am. Yes. Nice haircut, ma'am. Thank you. So yesterday there was a discussion over actually. Yesterday you should have attended the session. Mansi from other phone. Okay, Mansi, okay. Yes. Good evening, Manju. Good evening. Yes. And ma'am, until you say we will spam. For what? No distraction. I'm not getting you guys. Yes, I'm good. When is your birthday? Birthday on it is very close, but I won't say. Hey, why suddenly birthday becomes a topic? Spam hearts. Oh my god, thank you so much for the hearts, guys. Okay, so இன்னைக்கு வந்து let us just start the session da. So we are going to discuss modern physics. Hey, how you guys are? Okay, so let us. Hey, Kritika, you are really a mind reader. Yes, Kritika was right. Yes, நாளைக்கு வந்து கோபியா மேமோட பர்த்டே அதுக்கப்புறம் ஆக்சுவலாக வந்து நம்ம அஸ்வதி மேம் 1 month டிஃப்ரென்ஸ் இருந்துச்சு ஷி வாஸ் April 17 and me on May 17th. So yeah, duration of class வந்து இப்போ சொல்ல முடியாதுடா. Minimum of 3 hours. 3 hoursல 3 chapters. That is what my target. Let us see how it will be. Yeah, we Gusda. Oh my god, everybody is so smart, eh? When is the treat? When you guys are coming to Bangalore? Okay, illana I mean when is the next meetup? Adu vandu paatadukku appuram I will tell you da. I will tell you. Okay, so when we meet annekku vandu namma treat da. All teachers will give the treat. Oh my god. Other teachers. Yes, ma'am, energy ma'am with your class. Yes. Telegramல கிருதிகா ஆக்சுவலாக வந்து I'm trying to log in, but ஏதோ ஒரு ப்ராப்ளம் இருக்குடா ஸ்டில் மார்னிங் ஆன்வர்ட்ஸ் பிகாஸ் ஐ வாண்டட் டு கனெக்ட் நம்ம வாட் டு சே திஸ் ஒன் நோ நம்ம re-NEET ஃப்ரீ கிராஷ் கோர்ஸ் அந்த ஃப்ரீ கிராஷ் கோர்ஸ் வந்து ஜாயின் பண்ணுறதுக்கு வி ஹாவ் another செகண்ட் லிங்க் நீங்கள் வந்து பார்த்தேன்னா டெலிகிராமில் யூ வில் பி கெட்டிங் த ஆக்சஸ் ஃபார் ஆல் தி டீச்சர்ஸ். ஸோ அதில் வந்து ஐ ட்ரைட் பட் I'm not, I couldn't, but definitely in night I will make sure the Telegram is fine and I will connect with you people also. Yes, in Bangalore da. Okay? 3 hours session. Okay? So start pannalamada. Are you guys ready? Give me a fire if you're ready. Warm-up time is over. Now it is the time to start the session. Okay, Durga, you're in Bangalore. This is in HSR. HSR. Yes, I am getting a lot of fire. So, modern physics, the first chapter, we will be starting with the dual nature. Okay, we will be starting with the, is it visible? Okay, dual nature, but inga vandu blur irukku. Dual nature of radiation and matter da nama vandu first discuss panna porom. So adula vandu first enna we should know what is a photon. So now you guys have to, yes, white field, it is too far no from here. Okay, white field vandu I have visited 2-3 times, that's it. I have already given the plan da, it will come around 6 o'clock. 6 o'clock ku vandu nama channel live agum. What is the plan for this next 30-35 days? No worries. Okay, not today da, 17th. Okay, which PDF da Maran? Which PDF you are asking for? Thank you Harish, thank you so much. Which PDF you are asking? Maran. Yesterday's notes PDF is available, right? Yes or no? Let's rock it. Okay, anyway, I'm just starting the lecture da. Okay, weightage 3 to 4 questions we can expect. 3 to 4 questions. Okay, thank you guys, thank you so much. Not clear, okay, let me just check da. I don't know if anything has happened or what, or otherwise whatever I have I'll share with you people, no worries. Okay, thank you da, thank you. Shubha Sayanam. Okay, so now we are starting with the dual nature da. Please, now come back. Okay, so now dual nature la first vandu neenga vandu you should say what is photon, and the photon oda features vandu neenga vandu sollanum. Okay, photon na enna? It is actually energy packets da, correct ah? Photon na it is nothing but energy packets da, and also adoda energy value vandu we know it. What is the energy value? What is the energy of a photon? It is nothing but h mu, right ah? Illana we can say that this is nothing but hc by lambda. Why? It is moving with the speed of light. In the photon will be moving with the speed of light. Adinala we can say, yes guys, don't forget to like the session. hc by lambda we can write. Yena frequency and velocity vandu there is a relation. So adila irundha frequency vandu we can replace it as c by lambda. And also idukku vandu momentum irukku. Can you just let me know what is the momentum of photon? What is the momentum of photon? Everybody tell me. What is the momentum of photon? It is nothing but energy by c. Okay, or otherwise we can say h mu by c. Illana we can say that hc by lambda divided by c. So this will become h by lambda. Okay, so these equations are very important. Yena vanda question la. Okay, idellame vanda question depend panni we can use it. Okay, I got some confidence. Very good Hansika, very good. Yes, very good Manju. So now, yes guys, don't forget to like the session. Yes. Okay, thank you Durga. So now dual nature la first vandu we will be discussing about the photon. Photon na energy packets da, adoda energy vandu h mu da, and momentum vandu energy by c da. Okay, so next vandu this will be moving with the same speed of light da, and rest mass vandu we will be considered as 0. Okay, and we can't see this photon, only we can feel it. And why we are talking about photon? Yena in the photon is actually, okay, in the photon is actually சொல்லும்போது இது வந்து நம்ம ரேடியேஷனோட I mean what to say, in the particle behavior represent பண்றதுக்கு தான் we are using this photon. புரிஞ்சுதா everybody? ஏனா மாறன் we cannot just take this photon and we cannot just measure the mass. Okay, அது வந்து முடியாது. So we are considering rest mass வந்து 0 தான். Okay va? So now no, you can watch this. Just now only we have started. So in the photon vanda we have discussed. So now the thing is like we need to know the power. So power na enada? Power is nothing but energy by time da. So energy by time na I can go for h mu by t. Okay, so ipo vanda n number of photons irundiruchuna I can say that this is nothing but n h mu by t. Understood everybody? Give me a heart. Yes da, yes da. I'm also trying to. Already you can see that நம்ம sessions எல்லாமே வந்து already schedule இருக்கு. நம்ம live sessions ல பார்த்தா தெரியும். So I'm also trying to change some of the session for the 11th. ஏன்னா ஸ்டூடெண்ட்ஸ்க்கு வந்து there everybody wants the what is 11th grade topics. So let us see. Okay, I will also change, no worries. So இப்போ வந்து NH mu divided by T da. Correct? So this is what the momentum. Sorry, this is what the power. This is what the power. This is momentum. Okay, this is what the power. Now it is the time for intensity. What is intensity? What is intensity? Can you give me the answer for the thank you Nitin. Okay, so can you just give me the intensity or expression? What is the intensity or expression? It is nothing but the power divided by area da. So already we got the power. What is the power? N times the energy of the photon divided by T divided by area. Purinjidada everybody? If only one photon is there na, we can say that this will be energy of photon h mu divided by area into time. Got it? Everybody got it? Everybody got it? Yes or no? Please let me know. So in the equations in the beginning of the chapter lab, we should know some of the equations. In the equations the major arke. Okay va? So next can we go for radiation pressure? Are you guys ready? Please let me know. Radiation pressure. Radiation pressure. Radiation pressure. Are you guys ready for the radiation pressure? What is radiation pressure? So radiation, let us say nama light. Okay, in the light can push the object. Correct? Are you guys getting it? What I'm saying? Okay. So Nitesh, thank you da, thank you so much. Okay. So now what I'm telling, இப்போ வந்து நம்ம லைட்டுக்கு வந்து actually it can push the object. அதுதான் வந்து whatever we are calling the radiation pressure. So in the radiation pressure we have to consider two things. Okay, in the two things என்னன்னா இப்போ வந்து இந்த light is falling on a reflecting surface. Okay, reflecting surface. இது என்னடா reflecting surface தான். Okay, reflecting surface தான். And another one is absorbing surface. Okay, absorbing surface na இந்த photon will fall on it. Okay, அதுக்கப்புறம் it will absorb. Okay, absorbing surface. Got it? Got it everybody? So this is what the thing. So now we have the reflecting surface, we have the absorbing surface. So in the reflecting surface now we can say that in the photon will be falling on the surface, adukapram it will be going back. Understood everybody? Okay, yes, if you understood put red heart. If you're ready means give heart. Oh my god Durga, thank you so much, thank you so much. Okay, so yes, so in the reflecting surface in the photon will come and fall over here, adukapram it will go reflect. Okay, and absorbing surface na enna, it will fall and in the surface vande it will absorb, and the photon it will absorb. Okay va? So now the thing is like in the cases in the both the cases நம்ம radiation pressure வந்து different da. Okay, நம்ம radiation pressure வந்து different da. This will be coming as 2I by C. Okay, and absorbing surface in the radiation pressure வந்து I by C da. Now tell me da, what is I? What is I? Everybody tell me what is I? What is I here and what is C here? Quickly let me know. So நம்ம வந்து radiation pressure da we were discussing. அதுல வந்து reflecting surface ஓட radiation pressure find பண்ணனும்னா you can use this equation 2I by C. And also இப்போ வந்து absorbing surface na you can find it as I by C. I na very good Jahi, right? Jahi. And Daya, very good. Ranjit, very good. Intensity and C வந்து nothing but correct and Nidish. It is TVK. Very good. Very good. Very good. இதே அப்படியே you can write. Okay. C na speed of light da. So now the thing is like we just wanted to know நம்ம வந்து when we are talking about electron emission. Okay, when we are talking about electron emission, can you just let me know what are the three types of emission? What are the three types of emission? So we are just straightly going into the electron emission. Okay, electron emission la you have three types of emissions. What are the three types of emissions? First வந்து நம்ம thermionic emission da, correct? Thermionic emission da. And next வந்து yes, field emission. Very good. It is nothing but nama field emission. And third one is nothing but the photoelectric effect. Correct? Very good, Monisha. Very good, Mansi. Yes, I'm not wrong. Yes. Love learning. Yes, yes. Very good, very good. Okay, yes, Susie. Yes. So, appadina thermionic emission. And the name is what type of emission it is. What type of emission it is? Thermionic, thermal, heat. Okay. So, when we are giving heat energy, electron is getting energy and it will emit from the surface. Correct? Electron emission na enna? Electron ku vandu konjam energy kadaikanum. It wants to escape. Avloda. Correct? Appadina thermionic emission sollumbodhu the way it is getting the energy adu vandu yes heat da. Okay, next one the field emission na yes edachu oru field vandu apply pannanomla we will give a strong electric field and the strong electric field la irundhu it will be getting some energy, it will escape. And third one is the major one which we need to study in this chapter. Major questions vandu we can expect from the photoelectric effect. And guys, marakama like panniko, also share this video with your friends. We need to study a lot. And in the chapter advantage enna easy questions, predictable questions, and also easier we can understand. Okay, some equations based panni da in the chapter irukku, so we can just study easily. Okay, very good. So now photoelectric effect. Photo and the term irukilla, photo na light da. Correct? So on the term nala I understood in the emission is happening because of light. Ana all light cannot produce, or let's say all light cannot emit the electrons. Okay, adula vandu yes Mansi, very good. The light with suitable frequency. Okay, suitable frequency. Why we are saying suitable frequency? Yeah ma'am, why we are saying suitable frequency? You didn't mention about intensity and all, but right now you are talking about suitable frequency. Light with suitable frequency falling on a surface will result for the photoelectric emission. Correct, Ada? Am I right or wrong? Yes or no? Are you guys getting it? Yes or no? So photoelectric effect na simple ana or process da. Light will fall on the surface and the time la electrons will get the energy and it will emit or it will escape from the surface. Okay va? Ana vanda here we are specifying. Okay, here we are specifying light with suitable frequency. Yeah, we are saying suitable frequency. Yeah, na in the light kulla irukra. Okay, light is actually light vandu in the radiation vandu falling on the surface da. Okay va? So ipo vandu idu vandu or radiation da. Light vandu radiation na in the surface vandu or matter da. So definitely in the radiation vandu if it needs to interact with the surface, okay, அப்படினா இந்த ரேடியேஷனுக்குள்ள ஒரு பார்ட்டிக்கல் பிஹேவியர் இருக்கணும். ஓகேவா? பார்ட்டிக்கல் பிஹேவியர் இருக்கணும். அந்த பார்ட்டிக்கல் பிஹேவியர் தான் நம்ம photons. So actually வந்து even if you are saying in the light is actually interacting with the surface or interacting with the metal nalum, I have to specify this. Light, it is not, I mean to be specific, the photon will be interacting with the what, tell me. Photon is interacting with the, tell me the answer guys please quickly. Photon is interacting with the metal. Are you guys getting it? Yes or no? Please let me know. Please let me know, everybody. Yes or no? So what I was saying, simple da irukke, photoelectric emission da. So adukulla we know that the light should fall on the metal surface. So அந்த லைட்டுக்கு வந்து suitable frequency இருக்கணும். ஏனா அந்த லைட்டுக்குள்ள இருக்கிற photons da actually வந்து it is interacting with the surface. அப்படினா அந்த photonக்கு I mean there should be a sufficient energy. Okay, அந்த energy கிடைச்சா மட்டும் தான் actually வந்து இந்த எலக்ட்ரானுக்கு escape பண்ண முடியும். Okay, very good. Yes. So now we are going to focus on this photoelectric effect. So adala vandu first I am going to discuss enna nama work function da. Can you just let me know what is this work function? Yena ungalku theriyum what is this work function and all, you guys know it. Okay, enada in the work function, it is nothing but nama vandu sonnalla in the electrons need to escape from the surface. So adukkaga what was the condition? Adukku vandu ஒரு minimum energy கிடைக்கணும். கரெக்ட்டா? அந்த எலக்ட்ரானுக்கு sufficient energy கிடைச்சா மட்டும்தா it will escape. கரெக்ட்டா? அப்படினா phi நாட்ங்கிறது ஓகே அந்த வேல்யூ அந்த ஃபங்க்ஷன் இல்லனா அந்த physical quantity வந்து it is nothing but energy தான். ஆனா the minimum energy தான். okay, required for the electron to escape from the surface. Very good. Minimum energy required to eject the electron. Very good. So, if there is a photon, okay, we know that nama photon oda energy enna h mu da. Okay, so now the thing is like work function. If I am going to define work function na, adoda expression vara poradhu h mu naught da. What is mu naught? H na Planck's constant. Adu vandu constant value da. So what is mu naught? What is mu naught? Mu naught na, it is nothing but, tell me, I want the answer. So you people will also interact. No, now I can see many people have written what is work function. Now tell me what is this mu naught? Mu naught na adu vandu threshold frequency, ma'am. Threshold frequency na, ipo vandu இந்த எனர்ஜி பாக்கும்போது அதுல வந்து Planck's constant மட்டும் தான இருக்கு. So actually வந்து இந்த work function depend பண்ணி இருக்கிற ஒரே ஒரு வேல்யூ என்னன்னா threshold frequency தான். Which means அந்த எலக்ட்ரானுக்கு இந்த அளவுக்கு, okay, அந்த threshold frequency ஓட அவ்ளோ frequency இருக்கிற photon, when the photon is falling with this, then only photoelectric effect will happen. Very good, threshold frequency. So threshold frequency na enna? Minimum. Right now work function we have discussed, no? அந்த மாதிரி the minimum frequency required for the electron to escape from the surface of the metal. Got it? Got it? Understood everybody? Yes or no? Please let me know. Are you guys getting what I'm saying? So threshold frequency na in the minimum frequency da, and the energy வந்து replace பண்ணிருக்கு. ஏனா எனர்ஜில next இருக்கிற ஒரு வேல்யூ என்னன்னா Planck's constant da. அது வந்து constant value. Got it? So minimum frequency da. So now the condition I'm asking you, if so I'm giving you two equations. When the photoelectric effect will happen? Quickly let me know when the photoelectric effect will happen. When the photoelectric effect will happen. 1 or 2. When the photoelectric effect will happen. Very good, Preeti, right? Preeti, yes, I remember. Yes, Mansi, yes, very good. So when the energy of the photon is more than that of the work function, definitely photoelectric effect will happen. Otherwise, it won't happen. Got it? So this is what the basic idea. So always we know that in the photon வந்து surfaceல fall பண்ணும்போது அதுக்கப்புறம் the electron should get the, okay, அந்த electronக்கு அந்த energy கிடைக்கணும், அதுக்கப்புறம் it will escape. புரிஞ்சுதாடா? Okay, so அப்படினா இப்போ வந்து the photon which is falling on the metal, no, அதோட energy வந்து I have given you h mu. Okay, அதோட energy வந்து h mu தான். அப்படினா இந்த h mu is actually utilized for two purposes. Do you remember that purposes? Do you remember that purposes? இப்போ வந்து energy வந்து it is more than the work function. Okay, I have given that the energy of the நம்ம photonோட energy வந்து இவ்ளோ தான் இருக்கு. Okay, நம்ம எலக்ட்ரானுக்கு வந்து இவ்ளோ எனர்ஜி தான் வேணும். So அதுக்கப்புறம் இருக்கிற எக்ஸ்ட்ரா எனர்ஜி, yes, very good Preeti, very good Fatima, yes Diya ma'am, you are making physics easier. Thank you so much da, thank you so much. Yes, it is actually used for the kinetic energy. So energy of the photon is utilized for two purposes. Okay, phi naught na work function da, adu vandu oru specific material ku. Let us I am taking copper, and the copper ku vandu eppovume and value fixed da. Okay, now I am taking another metal, adoda value vandu fixed ah irukum. Okay, metals change agumbodhu and the value different ah irukum, ana vandu throughout and the specific metal la eppovume adu vandu same ah irukum. Okay, so this is what the energy of the photon in the equation vandu avlo important. Okay va? So now the thing is like this equation I can again replace. Energy of the photon definitely work function irukke. Okay, so when I can also say that this kinetic energy is also equal to potential energy at some point. Correct? So when the electron is falling, we will be changing the polarity. And the moment in the kinetic energy and the potential it will be, I mean the kinetic energy is completely converted as the potential energy. Potential energy na adoda basic equation, can you tell me? Potential energy, forget about this chapter. Okay, potential energy illana yes, potential energy oda expression, can you just give me the answer? Potential energy, do you remember electrostatic potential and capacitance? Potential energy mgh. Electrostatics mgh correct ada? Electrostatic potential energy, I have to be more specific. Electrostatic potential energy da. mgh, electrostatic potential energy. It is nothing but q into v da. Correct? Charge into v da. அப்படினா அது வந்து point charge க்கு the answer you have given is correct. Okay, அது வந்து potential da. kq by r na அது வந்து potential, not potential energy. Potential energy na we will be saying k q1 q2 divided by r, or otherwise we can say that this is nothing but q into v da. அப்படினா இந்த கேஸ்ல whenever I am talking about this photoelectric effect, இந்த q na நம்ம electron-ஓட charge da e. Okay, and v na நம்ம stopping potential vs. Understood? Getting it? மறக்காம like பண்ணிக்கோ everybody. Don't forget to like the session. I want more likes. Okay, more likes, which means more energy. Okay, so now yes Preeti, yes. Okay, so now we understood at some point in the kinetic energy completely converted to potential energy. Now this maximum kinetic energy I am replacing it as potential energy, which means charge into the stopping potential. Now tell me what is stopping potential? Do you remember this term? Stopping potential. What is stopping potential? I know you people will say before me. Okay, stopping potential na the potential at which the electron will get at rest, which means there is no flow of electrons, which means there is no current. So I can say that the photo current, when I'm talking about stopping potential, and the moment the photo current will be zero. Am I right or wrong? Yes, the potential at which the photo current becomes zero. Very good, Mansi. No flow of electrons. Very good. Yes, Saravana, welcome. So actually we understood when I'm talking about stopping potential. Okay, stopping. Okay, to whom? It is nothing but the photo current. Now tell me what is the photo current? What is this photo current? Usually current we know, so idhula vandu photo current. Enna and the photo current? So anybody knows what is photo current? Okay, photo current na ma'am, adu vandu current da. Okay, and on the photo irukradhula we can say that in the current is produced due to the light. Okay, so actually the light is falling. அதனால தான் electrons flow பண்றேன். அதனால to be specific we will say photo current. அதுக்கு வந்து அவ்ளோ definition எதுவும் தேவையில்லை. Okay, so that is the thing. Okay, so yes, very good Mansi. It is actually the current produced by the light. அதனால we will call it as photo current. Okay, so now stopping potential oda definition வந்து we got it. And we can just write the energy of the photon, which is equal to the work function plus the E into Vs, which means the potential energy. Now the thing is now you have studied all those things, correct? So now I'm going to ask you some questions and I want quick answers. Okay, so இப்போ வந்து I am going to increase the intensity. Okay, I'm going to increase the intensity. So in the intensity increase aachuna, what will happen to the energy of the photon? Will it increase or it will decrease or stay same? What will happen to energy of the photon? What will happen to the energy of photon when intensity, okay, intensity increases? What will happen to the energy of photon? CBT mode na enna ma'am? CBT mode na computer based tested ah. Okay, increases are very good, Samiksha, right? Yes, energy of the photon will remains same. Why? Tell me why it is remains same. Yena energy or equation enada h mu. H na Planck's constant, mu na frequency, intensity and frequency no relation, so it will be remains the same. Understood or what? If you understood, give me a heart. Intensity increases, energy of the photon will remain same. It won't change, it won't increase, it won't decrease. Yena energy of the photon na adoda equation h mu da. Okay, if mu is not increasing decreasing na energy la vandu change agada, so it will remain the same. Now what will happen to the photo current? Tell me what will happen to photo current? Tell me da, what will happen to photo current? Intensity increases. What will happen to photo current? Intensity increases na adoda meaning enna? Brightness increases. Okay, brightness increases. Okay, that is what actually saying. Intensity less na konjam dark ah irukum avlodha. Okay, so ipo vandu brightness increase aachuna photo current ku enna agum? It will also increase. Intensity increases na number of photons increases. Okay ma'am, number of photons increases, now what is the problem? Let it photons increases na, one photon will interact with one electron. So 10 photons irundha 10 electrons will be interacted. Sorry, 10 electrons will be emitted. Appadina the number of electrons emitted will increase. Appadina I can say that the photocurrent will increase. Yena current na flow of charges da. Okay, flow of charges da. So of course what will happen? The photocurrent will also increase. Understood or what? Yes or no? Please let me know. Everybody quickly let me know. Quickly let me know. Are you guys getting it? What I'm saying? Okay, and guys don't forget to like the session. I want more likes. Okay, also those who have not enrolled in the which session nama re-NEET crash course, zero price da, adula romba features irukku, lots of features irukku, like what is insta doubt solving irukku, also nama adu 24/7 you can ask at 1 am 2 am 3 am, no one will be asking, no one will say the service is not available, and the madri yarume solladu. Okay va? Understood? Okay, so this is the thing. Now I'm asking you, intensity increases. Now what will happen to the stopping potential? Will it increase or decrease? Will it increase or decrease? Will it increase or decrease? Stopping potential ku enna agum? Will it increase or decrease? Stopping potential. Very good. Same. Preeti, Susie, very good. It will also remains same. Why it is remains the same? Because yena we have studied. Okay, and the energy of photon increase ana mattunda stopping potential increase agum. Yena energy of the photon which is equal to phi naught plus EVS da. Correct? So idoda energy increase aachuna obviously this will also increase. Energy increase agalena definitely nothing will happen. So it will be remain the same. Okay, so intensity increase aachu illana brightness increase aachu illa decrease aachuna, these are the changes which is going to happen. It will only affect the photocurrent. So I can say that intensity will be directly proportional to the photocurrent. Okay, I got a very important information. The intensity will be always proportional to the photocurrent. Okay, now I'm going for another one. Nama frequency increases. Now what will happen? Energy of the photon will increase. Correct? Appadina I can say that the stopping potential, what will happen to the stopping potential? Energy increases, frequency increases na, energy increases da, which means what will happen to the stopping potential? It will also increase. Very good, Saravana, very good. It will also increase. Okay, so now in the frequency increase aachuna, what will happen to the photocurrent? What will happen to the photocurrent? It will increase, decrease, or remains the same? What will happen? Everybody tell me. What will happen for the photocurrent? What will happen to the photocurrent? Everybody tell me. Everybody. Yes, it will be remains same. Yena energy is just increase or decrease, or let's say energy increases na, adu vandu it can increase the it can give more energy for the electrons. Okay, extra energy it can use for traveling. Okay, kinetic energy use pannalam. Illa stopping potential will also increase. Yena kinetic energy increase aachuna andha alavukku nama potential energy increase aganumla. So stopping potential can also increase, ana idu vandu change agadu. Got it? Voice problem irukka? Can anybody let me know? Voice edachu problem irukka? Yes or no? Please let me know da. Please let me know. Voice ku edachu problem irukka? No. Fine. Okay. And now another thing is, right now we have understood these kind of things. Now we know that in the photoelectric effect na, okay, photoelectric, behind there is a cracking sound. Seriously. Others are saying no problem da. Maybe it is with your surroundings. Okay, you just check it. Okay. So now it is fine. Okay, done. Okay. So right now we were talking about, we understood it on the instantaneous process da. Okay. Ana when we are considering wave theory, yena, I mean till this year. Okay. So when we are discussing or when someone is saying idu the particle behavior in the light irukku, and the time varaikkum actually the light considered it as a wave. So அந்த டைம்ல they were saying இப்போ as per wave theory in the process actually it should take a lot of time. ஆனா experimentல they understood this is happening in instantly. Okay, and also according to wave theory in the intensity and the frequency, I mean there is a relation. Okay, intensity change aachuna in the frequency kuda change aganum, ana experiment paakumbodhu there is no such kind of relation. Okay, frequency increase aachuna nama what to say nama photo current la kuda change irukanum, that is also not happening. So this is the failure of the wave theory, which means experimentally we understood in the photoelectric effect it is the instantaneous process. Ana wave theory, according to wave theory, it is actually a time consuming process. Okay, little crack iruka. Is it fine now? Is it fine now? Can you just let me know? Is it fine now? Yes or no? Fine? Okay, only fine now. Okay, thank you. So right now we were talking about the what? We were talking about what? I forgot. What we were talking about? What we were talking about? Yeah. So nama wave theory da. So next ipo okay, we understood in the radiation ku actually particle behavior irukku. Appadina in the matter ku kuda actually wave behavior irukanumla, when it is interacting with the waves it should have a wave nature. So the wave nature da nama discuss panna porom. So in the matter kulla irukra wave behavior illana the waves we will call it as matter waves, illana we will call it as de Broglie wave. Okay, we will call it as de Broglie wave. Okay va. So adukku the wavelength what do you remember the equation? The wavelength lambda, which is equal to nothing but h by p. Okay, h by p it is nothing but h divided by mv. Illana I can say that this is nothing but h divided by root 2 me. Okay, and the e na nama kinetic energy. Ena kinetic energy and momentum is having a relation. Okay, kinetic energy na p square by what to say, p square by 2m da. So now adilirundha p ku we will be finding it as root 2 m into kinetic energy. Got it everybody? Yes or no? Yes or no? Yes or no? Why these many opened, that bulged eyes were coming? Okay, cracking while I was walking. Okay, so I need to stand like this. Oh my god, mic is still cracking. Okay, should I call someone? Hello. Is it okay? Let me also check that. Hello. Now it is okay. In between it is coming. Okay, fine. Okay, so next and also these graphs are also important. We have already discussed nama current and intensity order relation, adu proportional la irukke. So whenever we are plotting it we will be getting like this. And now this is nothing but nama current and frequency order relation da. Okay, frequency increase aachuna nama current order value la change edum varadu, ana frequency increase aachuna nama stopping potential will vary. Okay, nama stopping potential will definitely vary. And next one we know that inga the what is the intensity is increasing, ana stopping potential எப்பவுமே constant ஆ இருக்கும். Still okay, one second, I'll text to someone, so in between they will come and they will check. Give me a minute, da. Okay, so I think it will be sorted in few minutes. Okay, so yes. Okay, I'll just keep it like this. Okay. Yes. Lambda for gas, it will be coming as, we can just replace the energy value. Okay, energy value, it will be coming as 3 by 2 kBT. KB na nama Boltzmann constant. So, that one replace pannalam. So, what we will be getting 3 by 2 sollumbodhu and the 2 cancel out and we will be getting H divided by root of 3 m kBT. Okay. Now, let us go for the questions. Okay, wow. Okay. So now here we have the first question. Ready everybody? Ready? Yeah? Ready? Now give me fire. Everybody. Yes. So now first question, calcium plate has maximum possible radiation of wavelength lambda of 400 nanometer to eject electrode. Calcium plate has a maximum possible radiation that is coming as 400 nanometer to eject electrons. What is the work function? So work function or expression yenada? What is the expression for work function? We know that it is nothing but, okay, the work function is nothing but h mu naught da, which we can write it as hc by lambda naught. Yena in the question they have mentioned about the wavelength da. So adanala we can just replace it with the wavelength. So 400 nanometer it is coming. Okay, so right now you can just substitute the values. Nama Planck's constant order value on the 6.6 into 10 to the power minus 34 and C on the 3 into 10 to the power 8 and the lambda value on the 400 nanometer da. So 400 into 10 to the power minus 9. So while applying, what you will be getting? Idu vanda nama options vaakumbodhu electron volt la da we need it. So after finding this, you should divide it with 1.6 into 10 to the power minus 19. Okay, so the work function 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 400 nanometer. Okay, into 1.6 into 10 to the power minus 19. While solving this, what is your answer? What everybody is getting? Please let me know. What is the answer you guys are getting? What is the answer? Very good. So this will be coming as 3.1 electron volt. Okay, so this is the answer for this question. Some cracking sound. Now I'm just keeping it like this. Okay, I will show you the other question. You can just do it. Meanwhile, we will just fix the mic. Okay, you can just do this question. I don't know. They're saying cracking sound or something.
Was it outside?
I don't know.
Okay, should be 0.
Okay. Hello. Is there any problem in the audio?
Keep it first, now check the audio.
Hello. They were saying while I'm walking.
Walk and talk.
Hello. While walking, I'll speak. So this is something unusual. When it is coming naturally, it is fine.
No, it's not.
It's okay. Okay.
Careful with this while walking.
Okay, done.
They can see me, it's okay.
That's fine, it's fine.
That's fine, right?
Yeah.
Careful with this that you should not step on it. That's fine.
So everything is perfect. No, ma'am, everything is perfect. Yeah, everybody is saying that. Fine. Okay. So yes. So the answers are coming. Yeah. So answers are coming. Everybody is giving the right answer. Okay. So what is the answer? Option A will be the answer. Why it is option A? Why it is option A? Tell me. Why it is option A? We know that for this photoelectric effect to happen, okay, இப்போ வந்து இந்த photoelectric effect happen பண்ணனும்னா நம்ம work function விட energy அதிகமா இருக்கணும். So you should check. Okay, இப்போ வந்து இந்த light ஓட wavelength வந்து 400 தான். So அந்த photon ஓட energy வந்து hc by lambda தான். So while we are substituting this, you will be getting an answer which is going to be less than that of the 4 electron volt. So you will be getting the less value. So that is going to be the answer, option A. Now let us quickly go for the next question. Okay, so the threshold frequency for a certain photosensitive material is mu naught. Okay, the threshold frequency vandu mu naught da. Now the thing is like we are just giving some energy of the photon vandu illana adoda frequency of the photon vandu 2 mu naught da. Maximum velocity of photoelectrons is v naught. Okay va? So ipo vandu oru surface irukke, அதோட threshold frequency, okay, அந்த surfaceல இருக்கிற எலக்ட்ரானுக்கு எஸ்கேப் பண்றதுக்கு தேவையான frequency வந்து mu naught தான். இன்சிடென்ட் லைட்டோட frequency வந்து 2 mu naught தான். அந்த டைம்ல கிடைக்கிற velocity வந்து v naught தான். ஓகேவா? What will be the maximum velocity of the photoelectrons when the metal is illuminated by a light of frequency 5 mu naught? Okay. Got it? Okay. So I will be just writing over here. So what is happening? We know that first case la nama energy vanda 2h mu naught da. Why? Yena nama incident photon oda energy vanda 2 da. 2 mu naught da. Which is equal to work function, it is given mu naught. So h mu naught plus half into m into v naught square. Correct ada? Second case la enagum? This is coming as h mu 5 mu naught. Okay, 5 h mu naught da. Work function vandu change agadu ena same material da, plus half into m into v square. So what is the question? What we need to find in this? We need to find this v da. Can you find it? Can you find it? So in the equation solve pannitena, we will be getting in the mu naught vandu I will be taking over here. So I will be getting h mu naught, which is equal to half into m into v naught square. Now what I will be doing here, 5h mu naught minus h mu naught. Okay, in the equation I am replacing, which is equal to half into m into v square. This is 4h mu naught da. H mu naught oda value vandu already we got it, half into m v naught square, which is equal to 1 by 2 m v square. So m 1 by 2 1 by 2. So right now can you find this v value? Can you find the v value? Can you find the v value? What happened, Mansi? What happened, Hajir? Why your heart broken? You couldn't understand? Yes or no? What happened? Half mv square, that is what I have written, no? What is the confusion? Suddenly what happened? Yes, now answer vandu 2v da. Very good, Preeti, very good. Very good, very good, very good. Yes. This time OMR க்கு chance ஏனா வந்து அவங்க கன்ஃபார்ம் பண்ணி இருக்கிறது வந்து next yearல CBT தான் கன்ஃபார்ம். ஓகே, ஆனா இந்த இயர்ல it is not CBT. Okay? Are you guys getting it? Yes or no? Please let me know. Please let me know. Because I can see some broken hearts. I don't want to see broken hearts. It will make me broke. So please let me know. ஏதாச்சும் ஒரு explanation தேவையானா please let us know da. No, let us go for the next one. Yes. So now we will be getting 2 v naught. Now let us go for the next question. Okay. So now, yes, let us go. Okay. Saravana, what happened? Simple number h mu is equal to h mu naught plus half mv square. That's the equation. And we will apply it for two cases. First case is mu, what to say, energy of photon வந்து 2 mu naught. Second case is what to say, 5 mu naught. You will apply it. Then just the calculation. Okay. You just go back and can you just try one more time? Okay. So now in the question, what is happening? When light of a given wavelength falls on a metallic surface of stopping potential of photoelectron is 3.2 volt. If a second light having wavelength twice of the first light is used, the stopping potential drop to 0.7. What is the wavelength of the first light? This is the question. So right now you can just write one thing. We know the equation. What is the equation? H mu, which is equal to 5 plus E into Vs. Am I right or wrong? Am I right or wrong? Till this understood, everybody give me a heart. Give me a heart, everybody. Till this it is okay, na? Give me a heart. Because I am missing a lot of hearts. Nitin put some band-aid on the heart, I guess so. Correct. I mean, it looks like that. Not Nitin. Nitish, right? Yes. Yes. I like the purple heart also. Very good. Very, very looking so beautiful. So now, this is our equation. They have given this Vs. Correct? Both the cases. And this equation we need to replace. They have mentioned in terms of lambda. So I will be going for one thing. Hc by lambda, which is equal to 5 plus E into Vs. Okay. Both the cases the work function same da. Okay, they didn't mention the surface is not changing, something like that, they didn't mention. So now the thing is like, first case Hc divided by lambda, which is equal to 5 plus E into 3.2. Okay, so I can just write it as 3.2 E. Second case Hc by 2 lambda, which is equal to 5 plus 0.7 E. And what is the question? What is the question? We need to find the lambda. Right now you have two equations. Now you can just do one thing. This is the equation number 1. This is the equation number 2. Do 2 minus. 1 minus 2 you can do. What will happen? What will happen on the left hand side? Hc by lambda minus Hc by 2 lambda. Correct? Appadina I will be getting Hc by 2 lambda. Are you guys getting what I'm saying? In the point varakum, if you got na, give me a heart. Illana, give me a broken heart. Quickly. Everyone should give. No hearts are not coming. I think you didn't understand. Yes, Srivalli, Preeti. Yes, Mansi. Yes, Fatima. Yes, Jahi. Zara. Yes, Hajir. Jia. Yes, okay. I hope it's clear. So, I'm just handling this side. Hc by lambda minus Hc by 2 lambda will give me Hc by 2 lambda. Okay. Which is equal to 5 minus 5. 0. Next one, the 3.2e minus we will be getting 0.7e. So, Hc value we know it. Okay. Yes. So now you can just substitute the Hc value. Adilirundu you can find the lambda value. Can you do it? Can you do it? So this is what the equation. H na 6.6 into 10 to the power minus 34 and nama E value vandu 1.6 into 10 to the power minus 19 and give me the answer now. You can see the options. Give me the answer, everybody. H na 6.6 into 10 to the power minus 34 and E one to 1.6 into 10 to the power minus 19 and C one the what is it, number 3 into 10 to the power 8. So while solving this, which is going to be the answer? Do the calculation, everybody. So you should get option B as the answer for lambda. Okay, 2.5 into 10 to the power minus 7. Okay, wow. So now can we move on to the next question? Are you guys ready? Yes or no? Yes or no? Okay, so we are going for the next question. Here we have the next question. The de Broglie wavelength of oxygen molecule at 27 degrees Celsius is x into 10 to the power minus 12 meter. Okay, nama value they have clearly given. Okay, so ipo the wavelength value x into 10 to the power minus 12 meter da. The value of x da nama find pannanom. Adukkaga theviyana constant values ellame they have given in the question too. So idhula we should find the lambda, right? So on the lambda value what is going to be that? What is going to be that? Oxygen na gas da. So we can say that this will be nothing but H divided by root 2 into M into KBT. Correct? We have studied this equation. Now ipo H oda value 6.6 into 10 to the power minus 34 divided by root of 2 into M value 5.31 into 10 to the power minus 26. Okay, and KB, nama Boltzmann constant, adoda value enada 1.38 into 10 to the power minus 23. Okay, and what we have after that? T. T 27 degrees Celsius da. So we will be convert into this Kelvin. So you will be getting 300. So into 300. You should do this calculation and let me know what is going to be the answer. Let me know what is going to be the answer. Sorry, 3 empty. Yes. Sorry. 2 will be get cancelled and we will be getting. Yeah, correct. Thank you, Susie. Smash the like button, guys. Sarah is the only one who will talk for me. Yeah, root 3. So very good. So you will be getting option D as the Amada. It's a mistake from my end. Okay, again, nama chat koncham late irukke. Okay, so the answer on the option D da. Yes, Hajar, ask. Okay, now let us move on to the next question. So in the question just watch, just before this we have explained everything da, and the concept part just you have to go through it. Okay, don't spam. Okay, Saravana, you have to do multiple times. Okay, questions innu you have to do, otherwise there is no other option da. Nobody can increase the calculation speed in a single night. You have to. So light is incident on a metallic plate having work function is given. If they produce photoelectrons have zero kinetic energy, then the angular frequency. So what is the meaning of it? Zero kinetic energy na nama energy of the photon which is equal to nama work function da. Understood? Everybody understood? Yes, Sanjay, thank you so much. Okay, so yeah, tell me. So if you understood, energy of the photon will be equal to phi. Why? What is the reason? Yeah, they have clearly mentioned kinetic energy zero da. Right now we need to know the angular frequency. I know nama work function oda expression enna h mu da. Okay va? Angular frequency and frequency. What is the relation? Frequency is nothing but, can you give me the equation in the chat box? Frequency or expression, it is nothing but omega by 2 pi. So what I will do here, I will just replace, okay, h omega divided by 2 pi, which is equal to nama work function da. So nama work function into 2 pi divided by h will be giving me the angular frequency. Understood everybody? Yes or no? So the work function value is already given in the question. H value we know. All the rest of the values we know. So tell me. Do the calculation and check the values. Check it again. Very good, Susie. Very good, love learning. Very good, Fatima. Very good. Others, don't forget to like the session. Everyone should like the session. Everyone. Don't even show a selfish behavior here. Yes, very good, very good. Linkeshwar, right, yes. The answer will be option D, the 1.04 into 10 to the power 16 da vandu nama answer varaporom. Now we are going for the another question. Again, let us do some simple question to make our what is a confidence level little high. Okay, so here is the question. I hope everyone will be giving the answer. Hey, class start pandradhula like even it is not 1 hour da. How could I give a break? No way, Diya. Okay, இந்த சாப்டர் முடிச்சதுக்கு அப்புறம் கூட I won't give break. Okay, இன்னைக்கு வந்து பிரேக்கே தேவையில்லடா. இந்த சாப்டர் வந்து ஆல்ரெடி முடிச்சிருச்சுல. We will be going for some more question. அதுக்கப்புறம் we will go for the next chapter. Okay. Yes, Hero, good evening. Okay, so the energy of a photon is equal to 3 kilo electron volt. What is the linear momentum? Simple. Linear momentum is nothing but energy by C. Energy is already given. C value you can just do it. But ana vandu idla vandu we know that nama energy vandu electron volt la da, answer vandu kg meter per second la da irukke. So you have to convert. Okay. So everybody give me the answer for this question. Simple ana calculation. Very good, very good, very good. We will be getting option B. Very good. So now let us move on to the next question. Yes. So here we have the next question. 2 milliwatt laser operates at a wavelength of 500 nanometer. The number of photons that will be emitted per second is number of photons emitted per second, which means we need n by t. Okay, wow. So how we will be finding this? Let us just go back to the equations. So when the equations vandu paakumbodhu nama what is a power da given. So power oda expression enada n into h mu divided by t da. Okay, energy by time. We already discussed this equation, right? I have changed Sanjay. Sanjay, I think you are just going little back. Root to 3 vandu I have changed to 3. Okay. Correcta? Okay, you are asking can we use? Okay. Okay, but ana vandu energy of photon we don't know na. That is what. And for the gas ku vandu we will be using the equation. Adula vandu we cannot just go for this equation. Purinjadada? Which question was the previous one? Okay, you guys can do this. You are asking about this energy of a photon equal to. This question you are asking. This question. So idhula vandu what is your equation? Root 2 m e. Okay, and the e vandu kinetic energy. Okay, adu vandu photon oda energy alla, kinetic energy da. Purinjadada? Got it? And also both are different. Try to understand. Okay, guys, just focus over here. It is not a confusion which is happening with Sanjay. Okay, it is happening with everybody. So just understand. Ipo vanda when I'm just talking about the what is a energy equation. When it comes to radiation, anga vanda energy of photon da. And you cannot say that energy of photon na kinetic energy illana adoda potential energy andha madri solla mudiyadhu. Photon ku vandu internal energy mattum da irukke. It cannot have kinetic energy, potential energy. Ana vandu that is what is asked over here. Okay, we will be using root 2 me and everything when it comes to particle. Okay, particle. When we are talking about particle, we will be discussing that. Understood the difference, everybody? Okay, and the difference is very important. First vandu nama vandu discuss pandrathu about radiation da. Okay, radiation la sollumbodhu idu da vandu expression. Okay, and the radiation la photons the particle behavior. Ana vandu right now this lambda which is equal to h by p ellame vandu it is actually matter wave. Both are different. Okay, so yes. So now let us go for this question. In the question la power vandu n h mu by t da, n by t da nama vandu find pannanom. So power divided by h mu will be giving you n by t. All the values is there. Instead of this mu you can replace it as p divided by h c by lambda So this is what? N by T. All the values were there. Can you find it? Can you find it? Yes, 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 yes. Very good, Sarvana. Very good, Linkeshwara. Very good. Others, others. Yes. Now answer one the option A da. Okay. So now let us go for some other questions. Okay, இப்போ வந்து proton இருக்கு, electron இருக்கு, alpha particle இருக்கு, have the same energies. Energies வந்து same தான். Their de Broglie wavelength will be. Okay, so இதுக்கு வந்து whatever you said Sanjay and the equation வந்து we can use. Okay, what was the equation? Lambda which is equal to h divided by root of 2me. இந்த ஒரு equation மட்டும் தான் we can use. ஏனா they have clearly mentioned energy வந்து same தான். So we should choose an equation which is having energy. Okay va? So right now in the equation la paakumbodhu h vandu constant da, 2 vandu constant da, energy is same that is mentioned in the question, which means lambda is proportional to root m. Correct? Now can you give me the answer for this question? Can you give me the answer question? Can you? Very good, very good, very good. Very good, Susie. Very good, very good. We will be getting the answer as what is a B. ஏனா வந்து mass of alpha particle வந்து it is more. So இது வந்து ஒரு inverse relation da. So mass of alpha is more and then the proton, then the electron. So of course what will happen? The lambda will be more for the electron, then for the proton and then for the alpha. Are you guys getting it? Yes or no? Yes or no? Can you give me a heart if you understood? Can you give me the heart? Can you give me the heart? Leo, all the important chapters ellame vandu we already discussed da. Okay. Yes. So now let us move on to the next question. Idukapram we can go for the chapter atom. Okay. A proton and an electron have the same de Broglie wavelength if Kp and Ke be the same de Broglie wavelength da. Okay. Proton oda de Broglie wavelength and electron oda de Broglie wavelength வந்து same da. If Kp and Ke is the same kinetic, the kinetic energies of this one, choose the correct relation. How will be the relation between kinetic energy of proton and the electron? இதுதா வந்து நம்ம வந்து find பண்ணனும். So right now I am writing this equation, root of 2 into mp, okay, into Kp, which is equal to h divided by root of 2 me Ke. Correct? So இப்போ வந்து பார்த்தேனா I can just write it as in the two will be get cancelled. So now I'll be getting root of mp Kp will be equal to root of me Ke. Now I'm squaring both the sides. So I'll be getting mp Kp which is equal to me Ke. Okay, wow. So now what I'm going to do da? Now what I'm going to do? I'm going to do one thing. I'm going to write Ke. So what is going to be Ke? It is nothing but mp by me into Kp. Correct? So now this ratio will tell you what is the answer. This ratio will tell you the answer. Okay. If I'm giving the break, na, you people will run away. I don't want that. How many of you want break? If you want break, na, give me a yellow heart. Because Sarah has already given a yellow heart and I liked it. So I felt like I can ask. Break venu na, you can just give me a yellow heart. So in the ratio mass of proton and mass of electron ratio, if you know na, definitely you will be getting the answer. Give me. So what will happen? We know that mass of proton is greater than mass of electron. So mp by me will be definitely greater than 1. Appadina I can say that Ke will be greater than Kp. So what is going to be the answer? What is going to be the answer? Give me the answer, everybody. Give me the answer. No much yellow heart, so we'll continue with atom. If you don't want break means put purple heart. Yes. Those who don't want break, give me purple heart. Very good. Saravana, C, yeah. Okay, very good, very good. So we will be getting option C as the right answer. Very good, very good, very good. So now, can we go for the another chapter? Can we go for it? Yes, lots of purple hearts I can see. So let me just quickly go for the other chapter, nama atom. Okay, so atothula vandu ivloda we need to study. Okay, there is no much things to study. Just chemistry la irukkiradhu adhe padi you can just convert here. Okay, I am thinking the correct explanation but ticking the wrong option. Idu vandu or disease da. Okay, idu vandu disease. Idu vandu again I mean we got again a second chance da we got it. Okay, adu vandu miss pannama you have to. Okay. Okay, so yes. So atom la first vandu we should understand about the Thomson's atomic model. So adu enna it is nothing but the plum pudding model da. Okay, so in order 10 minutes la we can finish this chapter. Okay, 10 minutes explanation podum da in the chapter ikku, rest everything is done. Okay, okay, so as we have expected we can finish the entire 3 chapters in 3 hours maybe. Okay, even lesser time la we can finish. So Thomson's atomic model da adu vandu plum pudding model da. Plum pudding model na enna, in the negative charges is spreaded over there. Okay, the positive charges is spreaded over in a space and electrons is something like the seeds. Okay, so that is what illana we can say the plum. Okay, so in the pudding la irukra plum madri da irukum. Okay, so this is Thomson's atomic model. Adukapram we will be having the Rutherford's model. So Rutherford was explained on the basis of an experiment. That is the gold foil experiment. Okay, that is you guys know it because detail you guys have studied in the chemistry chapter, right? So can you just give me what is the points regarding this gold foil experiment? Can you give me the answer? Okay, what are the conclusions he got? What are the conclusions? Gold foil experiment. We understood almost all the particles reached the target. Okay, or let's say they kept a photosensitive material. So almost all the particles have spotted. Which means in the atomkulla almost majority ana space actually empty da. Okay, and we know that few particles were deviated, few particles were exactly going and coming back. Okay, which means anga oru strong repulsion irukke. So and the strong repulsion is actually for a very small region. Adudha what we are calling it as the nucleus. Okay, adudha nama nucleus. So and the nucleus is concentrated at a point in the atom, and the problem is like he couldn't explain anything about the stability. Okay, he couldn't explain anything about the stability. Also, he couldn't explain about the spectrum. This was the 2 drawbacks of the same thing. Got it? Okay. So now, Bohr has made some more analysis about it. So the major he has given an explanation for stability, and he could explain about spectrum of hydrogen or hydrogen like ion. Okay, so again anga kuda oru what is a limitation irukku, ana he could explain about the hydrogen like atoms ions they could explain. So in the Bohr atomic model la first in the atom model is applicable only for hydrogen or hydrogen like ion. So now first one is nothing but Vz in the Bohr has mentioned the electrons is actually revolving around the nucleus. Okay, so when we are talking about the stability, okay, electrons are revolving around the nucleus. So when it is just rotating, okay, when it is rotating, definitely after some time it should lose its energy, it should radiate its energy, and finally it will be coming to rest, or let's say it will fall on the nucleus. Hey, are you guys sleeping? Are you guys sleeping? Yes or no? Can you give me a fire? Everybody. So I think you guys don't like concepts, right? Everyone, I think everybody is very confident about the concepts. You guys need some practice only, guys. Yes or no? Yes or no? Okay, yeah. Nobody is responding, so I was felt like everyone gone, sleeping. Ha, ma'am. In the class, we can smoothly sleep. Yes, I'm not sleeping. Okay, thank you, da. Thank you for the fires. Thank you. Okay, so அப்படினா first thing வந்து definitely the electrons will be rotating and finally it should fall on the nucleus. ஆனா வந்து அது வந்து it is not happening. That is what the stability question, why it is. So he said like it is actually moving in a fixed orbit. Okay, in the electron is actually moving in a fixed orbit. அந்த fixed orbitக்கு ஒரு எனர்ஜி இருக்கும். அதனால இந்த electrons வந்து எப்பவுமே அதுல தான் எப்பவுமே rotate பண்ணும். Got it? அப்படினா I can say that when it is rotating, it should have a centripetal force, right? What is centripetal force? mv square by r, correct? It is nothing but mv square by r. So who is providing the centripetal force here? Can you give me the answer? So இப்போ வந்து இந்த electrons is revolving around the nucleus. So அதுக்கு வந்து if it is moving in a circular path, it should get a centripetal force, and the centripetal is provided by நம்ம electrostatic force. நம்ம electrostatic force தான் actually வந்து இந்த what to say, this force is providing. Okay, this is for Bohr. Okay, so now yes, so now this is what his first one. Second one is definitely இப்போ வந்து circular path தானா, so அதுக்கு வந்து angular momentum இருக்கணும், கரெக்ட்டா? angular momentum இருக்கணும்னா angular momentumத்தோட expression it is nothing but mvr. This is having a value, this is also a constant value, nh by 2 pi. n னா நம்ம orbit, okay, நம்ம energy I mean we will say principal quantum number. Okay, actually வந்து we know that there will be energy levels, so depending upon the energy levels this will also vary. ஆனா வந்து ஒரு specific ஆன energy levelக்கு வந்து this value will be fixed. So this is what the another one. Next one is, let us say இப்போ வந்து இந்த electronக்கு it is feeling bored. Okay, it wants to go to the higher energy level. Okay, it wants to go to the higher energy level. அப்படினா what is the requirement? இப்போ வந்து whenever you wanted to go to the upstairs, you should have a energy, right? Okay, energy இல்லனா you cannot go there, correcta? அப்படினா what will happen da? So this electron will move from the lower energy level to higher energy level. Na it will absorb a photon. Okay va? It will absorb a photon. Okay, once it is reaches the higher energy level. Now not for a break for you, ma'am. Thank you, Sarah. Thank you so much. Okay, so இப்போ வந்து when it is, okay, இப்போ வந்து இந்த electronக்கு actually வந்து it needs to come back. Okay, higher energy level இருக்கு, ஆனா வந்து அதுக்கு வந்து higher energy level கொஞ்சம் time மட்டும் தான் it can stay up to. Okay, so after that what will happen? It will come and fall, or it will come to the lower energy level. So அப்படினா when it is coming from higher energy level to lower energy level na what it will do? இந்த photon, okay, இந்த absorb பண்ண அந்த photon இல்லையா, அந்த extra energy, இந்த extra energy வந்து it will emit. Got it? Are you guys getting what I'm saying? Yes or no? Give me a red heart if you understood, everybody, quickly. And the red heart வரும்போது I should get the energy. Okay, it is something like right now the அந்த higher energy stateல இருக்கிற electron மாதிரி. Okay, இந்த stateல அவ்வளோ not at all interested. நம்ம students எல்லாமே வந்து they are doing something else. Okay, so அந்த மாதிரி எனக்கு வேண்டாம்டா. You people have to give some energy for me. Yes, fine. So இப்போ வந்து when it is going one energy level to the energy level na, it should either release or absorb a photon. So which means when it is going from one energy level to another energy level, from E2 to E1, so on the time it should absorb, or let's say it should release a photon which is having nothing but H mu. Got it? Understood? So this is what the thing he has explained, and he could explain only the spectrum related thing, he could explain only for the hydrogen. Okay, so idhula vanda innum few points irukke. Okay, so few points irukke, which means நம்ம radius, okay, இப்போ வந்து nth orbit la da irukke. So the nth orbit oda radius enna, so the radius oda value in the equations ellame வந்து by heart பண்ணனுமா? I mean that is not required. ஆனா வந்து one second. Okay, so ana vanda what is happening, you should study this relation. Okay, in the radius will be proportional to n square by z. Okay va? And also radius vanda we should study it as n square by z. Proportionality vanda you can study illana idoda calculate பண்ணும்போது you will be getting 0.53 Armstrong. You can either study that as well. Okay, ground state part in the ground state la irukumbodhu it wants to go to upstairs. upstairs la irukumbodhu it wants to go to downstairs. Okay, so in the time ila if it needs to go to higher energy level na need additional energy, adukaga it will absorb a photon. If it is at the higher energy level, it needs to come to the ground energy level na, it should release some energy, so it will release the photon. That's it. Got it, Linkeshwara? Okay, so now in the Rn, nth orbitoda radius vandu will be proportional to n square by z da, and also velocity vandu paakumbodhu it will be proportional to z by n da, and energy, okay, energy at the nth orbital will be proportional to z square divided by n square da. Are you guys getting it? Yes or no? Yes or no? Yes or no? Yes or no? So these equations you have to study. The velocity order relation, radius order relation, energy order relation vandu mandatory. We can get the question. Ana vandu in the constants ellame vandu you can skip it. For the radius you can study that value 0.53. Okay? So next vandu time period. So when the electron is revolving around the nucleus na, it will go from here and it will be coming back to the same position lada. So on the time ila what is going to be, okay, how this time period is proportional. Okay, time period will be proportional to n cube divided by z. Okay, you have to study this relation also. Ena idellame vandu buffering sound edachu problem irukada, cracking again. Okay, now it's fine. Now is it fine? Please let me know da. Is it fine now? It's not audible. Is it okay now? Okay, okay, fine. Okay, 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 fine. So ipo vanda we will be we have discussed about the nth orbital order radius. Nth orbital order radius vanda it is nothing but what we have discussed, it is proportional to z square by n, and nama vanda we have discussed about the velocity, it is nothing but n square by z, sorry, n by z, then the energy, sorry, I have mentioned it wrong. Okay, so nama radius na it will be proportional to n square divided by z, correct? And nama energy vanda z square by n square, nama velocity vanda z by n. So in the proportionality you have to study along with the time period sollumbodhu it will be n cube divided by z square da, and the frequency, angular frequency sollumbodhu it will be z square divided by, exactly ulta. Okay, yena time period and omega vanda it is inversely proportional, so we can say that this will be proportional to z square divided by n cube. Clear ada? Till this clear? Everybody give me a heart if you understood, if you are clear about all these relations. In the relations use panni many questions will come. Okay, you don't have to study the entire values, all the constants, nothing is required. Ana vanda in the relation mattum you have to study. Okay, got it? Okay, so this is what the thing. Next one is nothing but the kinetic energy, potential energy as well as the total energy. Okay, wow. So now, is there any problem? Everything is okay? Right? Yeah. So right now, nama vanda discuss panna poradhu enna nama kinetic energy da. So kinetic energy oda expression vanda z d square divided by 8 pi epsilon naught r da, and potential energy and kinetic energy sollumbodhu, potential energy and kinetic energy sollumbodhu we can say that there is a relation. Okay, nama kinetic energy will be equal to, okay, will be equal to minus potential energy by 2. In the relation vanda study panniko, same relation we are studying in electrostatics, same relation we are studying in the gravitation. So there is no such new things we are studying. Same thing, kinetic energy is proportional to minus u by 2. Now total energy and kinetic energy is having a relation. The total energy is nothing but negative of kinetic energy. Eppovume vanda nama kinetic energy positive ah irukum. okay எப்பவுமே நம்ம kinetic energy வந்து பாசிட்டிவா இருக்கும் guys you have to give me some likes everybody okay so இப்போ வந்து நம்ம kinetic energy வந்து எப்பவுமே பாசிட்டிவா இருக்கும் ஆனா potential energy and total energy வந்து it will be always negative that is what the one understanding so if this is the kinetic energy if I need the total energy I can put a negative sign okay இப்போ வந்து if I need to get the potential energy I can just multiply it with 2 with a negative sign are you guys getting what I'm saying yes or no yes or no yes yes guys smash the like button okay and the like button at least you can check whether it is working or what right okay hey why this much of noise okay so now this is what the relation now total energy and potential energy order relation வந்து you guys have to give me what is the relation connecting total energy and potential energy kinetic energy versus potential energy I have mentioned total energy versus kinetic energy I have mentioned total energy versus potential energy வந்து you have to discuss you have to tell me what is that everybody you should tell what is the relation you can see the values and everything adula irundhu you can tell me Z na nama atomic number da Z atomic number okay very good total energy is not hey total energy is yes very good Mukesh Saravana yes very good so it will be coming as U by 2 the potential energy oda value da vandu it will be coming as minus Z square divided by 4 pi epsilon naught so definitely kinetic energy is minus U by T na total energy will be that I said it is already negative da appadina you will be getting these relations everyone should study these relations yena idoda answer kadachena there is no other problem okay yes Fatima U is equal to 2 into total energy will also work okay so these are the things and now you are going for the okay ipo vanda we have discussed about the absorption spectrum and emission spectrum when it is absorbing photon or when it is releasing photon it will be showing a spectrum so on the spectrum da nama vanda discuss panna porom for the hydrogen adoda equation enna na 1 by lambda if you need to know the wavelength of the photon which is released so it will be coming as 1 by lambda into r na nama Rydberg constant da into 1 by ni square minus 1 by nf square into z square so when I'm talking about this z okay when I'm talking about this z is nothing but the atomic number da for the hydrogen this value will become 1 and this equation will be coming as 1 by lambda which is equal to r into 1 by ni square minus 1 by nf square understood ma'am minus will not come for what does Saravana you're asking for the total energy already in the potential energy negative thanada when we are putting again a negative sign what will happen it will become positive so that is not possible total energy in a negative tha understood okay so idu da vanna nama expression 1 by lambda which is equal to the Rydberg constant into 1 by ni square minus 1 by nf square z value vandu 1 da so let us say ipo vanda the what is nama what is the ground state vandu always we will represent it as n is equal to 1 okay many students will be having a confusion n na first energy state I mean n is equal to 1 vandu first energy state illada n is equal to 1 vandu it is nothing but the what to say n is equal to 1 vandu what was that ground state da okay I'm losing the connection I don't know okay it is nothing but ma'am while you upload PDF send this handwritten notes also sure it will be coming along with that no worries whatever I taught here this exactly same thing you will receive okay and what are the questions we have skipped in the class illa adellame vandu you will get it and before that let me just tell you one more thing okay so many students okay how many of you are new to this channel can you just please let me know how many of you are new to this channel so if you are new to this channel na you can see one thing okay nama sessions la ellame vandu nama description box paathena okay just let me check Okay. This is not coming. Okay. So, நம்ம sessionsல நீங்க வந்து பார்த்தேனா நம்ம description boxல okay okay yes நம்ம description boxல first link join the free re-NEET crash course. So இதுல வந்து click பண்ணிட்டேனா you will be getting into the what to say directா வந்து உங்களுக்கு I mean you will be getting the access to the app. Okay, அந்த appல இந்த appல வந்து you can just download இல்லனா வந்து இந்த செஷனுக்கு அப்புறம் comment boxல கூட you will be getting it. So இதுல வந்து buy now option இருக்கு. Okay, so இந்த buy now option you know that நம்ம 5000 rupees ஓட கோர்ஸ் தான் வந்து இந்த re-NEETல we are giving. நம்ம re-NEET தமிழ்நாடு ஸ்டூடண்ட்ஸ் வந்து அவ்ளோ okay நம்ம May 3rd exam முடிஞ்சதுக்கு அப்புறம் many students came back and give a lot of appreciation. So நம்ம ஸ்டூடண்ட்ஸ்க்கு வந்து right now they need the help. So அதுக்காக we are giving this course for zero price. So idhula vanda you just need to put your mobile number or through your Gmail ID you can just log in and after adukapram. So right now if I'm trying also maybe I won't. Okay, let me check. Okay. So yes, so idudha vanda nama yeah this is what my course is. Okay, idhula vandu paathena you will be getting this course details. Okay, so idhula vandu you can see nama chemistry class irukke, biology class irukke, physics class irukke. So ovvoru sessions ume whatever be the upcoming sessions ellame vandu inge irukum. So idhula vandu you can see right now it is getting updated. Okay, so you will be get it. And now another thing is like performance. Okay, performance based na definitely inga vandu test you can attend. Okay, in the test vandu neenga paakumbodhu here you can just see the test, my test. Okay, so in the my test paathena you will be seeing some questions which means nama session mudinjadukku appuram you will be getting some of the test series. So on the test vandu you can do it. Adukappuram if you are going to the performance side you will be get to know most all the details ellame vandu you will be getting. Okay, so adu vandu leaderboard based da. So anneki vandu whoever has written that test avangaloda ellarodeyume result vandu it will show. adula vandu ungaloda position enna adellame vandu it will show. Okay va, and also ipo vandu edachu oru session is going on. Okay, edachu oru session going on. So in the session la vandu edachu oru session is going on. Okay, edachu oru session going on. So in the okay, so in the session la vandu you can just ask. Okay, idu vandu right now I didn't do in a proper way. Okay, so ipo vandu if you have done na inga vandu oru option irukum ask the doubt or question mark varum. Okay, question mark vandena definitely you will be what is it, you can just enter into it and adula vandu whatever be on the screen la whatever be the things there adellame vandu you can ask. Okay, on the screen la irukra ovvoru point me you can ask in the what is it doubt session. You can drag anywhere wherever you have the doubt you can just post your doubt, you will be getting the answer. So appo vandu you will be asking okay what is the special in it ma'am. So it is actually oru AI da ungalku vandu and the answer they will give. Okay, this one is classica. Okay, should I join? Yes, of course Mukesh you can join. Yena vandu question practice da in the time la you need it. Okay, and also instant doubt solving 24/7 you will be getting the doubt solving. Okay, 24/7 which means 1 AM you can ask, 2 AM you can ask, you will be getting the answers. So yes, Ved AI, yes exactly. So adu vandu actually vandu nama NCERT base panni da and the AI has created. So definitely you can do one thing, you can just get the I mean once you are enter into it all the answers coming from based on the NCERT da. Yena Google ellame vandu if you are just checking now what will happen, you will be getting multiple answers. Ipo in the last exam la kuda nama physics oda exam la there will be a question which is confusing, significant figures nama 7.7 answer vara on the question. And the question la many students made a mistake. Yena they used some other rules which is apart from NCERT. So eppovume vandu NCERT stick pandrathu avlo important. Okay va, got it. So that is what the thing. So everyone should do one thing. I mean till now you didn't enroll. I just wanted to know how many of you are already enrolled in this. So please let me know in the chat box how many of you are already enrolled. I know I mean in the madri oru I mean when I'm just discussing about the crash course and everything in the views vandu drop agum enake theriyum, but ana vandu idu vandu maximum number of students vandu utilize aganum. Yena avlo better nama offline la kedaikira madri avlo perfect ana oru course da nama students ku vandu zero price la we are giving. So we just wanted to make sure ovvoru students kume adoda benefit kedaikanum. So that is what joined already. Very good Jason. yes, love learning, yes, marumani, yes, yes, very good, very good, very good. So adula irukra test ellame vandu you can access. Also nama AI you can utilize, and all the answers will be based on NCERT da. Okay, yes, yes, Mukesh, don't forget what. Okay, yes, okay, Monisha, okay, Fatima, yes, Durga, okay, yes, Sarah, very good, very good. Okay, so these are the things. Now let us come back to this. Okay, so ipo vandu we have these many series: Lyman, Balmer, Passion, Bracket and Fund. So idhula vandu paathena, when it is okay from infinity, okay, from the nth orbit, from the infinity, if the if the emission is happened nalum, okay, if the photon is coming from infinity to the ground state, if it is coming to the ground state, if it is coming to the ground state na, I should say one thing. I should say one thing, okay, if it is coming to the nama ground state na, when I'm discussing something else, no, again I will just lose the connection, that is the problem. Okay, so idu vandu nama ground state illana, definitely I can say that that is nothing but Lyman series da. Okay, so adukku Lyman series na adukku ore oru condition, nama final energy level vandu 1 ah irukanum, which means ground level ah irukanum. Okay va, ana vandu initial vandu just above this, which means 2 ah irukalam, 3 ah irukalam, 4 ah irukalam, 5 ah irukalam, infinity ah irukalam. Okay, so that is what the thing. Next vandu if let us say in the wave is actually, sorry, in the photon is actually coming from infinity to the ground state. So I'll be putting the values here. What will happen? Rydberg constant into 1 by ni na 1 da, Lyman series illada, so adanale ni square will be coming as 1 minus 1 by infinity square. While I'm doing this, I will be getting this value. I will be getting the lambda value as 1 by r. Purinjadada? Are you guys getting it? Yes, thank you Monisha for the reminder. Okay, so right now we have, yes, we have found that the final energy final energy level vandu it will be 1 da, and also we will be having the infinity il irundha nama final yes, initial energy state ingiradhu it is actually infinity na, definitely nama lambda value varaporadhu 1 by r da, and idu vandu irukra oru region enna, okay, the lines will be formed in the UV region da. So in the madri I have written for the rest of the series as well. For Balmer, for Passion, for Bracket, for Fund I have written. So Balmer na the final energy level vandu n is equal to 2, which means first excited level ah irukanum. Okay va, so next vandu Passion na nama final energy level vandu second excited state ah irukanum, which means n is equal to 3 ah irukanum. And Bracket na in the nama final energy level vandu 4, which means third excited state, and Fund na it will be coming to the fifth energy state, which means nama fourth excited state. Okay, stay hydrated Dora ma'am, thank you da, thank you so much, thank you so much. Yes, so these are the things we should learn from these values. So now this is a nama radius find pandradhukku irukra equations da, you can just skip it. So these are the things we should study in the atom chapter. Now can we go for the questions? Are you guys ready for the question? Are you guys ready for the question? Yes or no? Yes or no? Give me a fire if you are ready for the questions. If you are ready for it, please let me know. Value of r 1 into 10 to the power 7, right? Yes, I think so. Yeah, 1.1 into 10 to the power 7 per meter. Adha vandu Rydberg oda value. Yes ma'am, therike withdraw, that is what I'm hearing for the first time. நான் தெரி மூவி வந்து பார்த்துருக்கேன், ஆனால் வந்து அந்த மீனிங் எனக்கு தெரியலை. Yes, 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 very good. Okay, so now we are moving on to the first question. So you can do this question, guys. Yes, in Rutherford's scattering experiment, when a charge Z1 and mass M1 is projected towards a target nucleus of charge Z2 and the mass M2, the distance of closest approach is, okay, I forgot to teach two things, okay, idukapram I will teach, okay, the energy of the photon projected charge is, okay, power is 7, no, 7 is the power, correct alla, Rydberg constant, 1.1 into 10 to the power 7 per meter, yeah, I think it's correct, I will also verify. Oh, no, it is 7 only. I'm also a bit confused now. Ten to the power 7, da. 10 to the power 7. It's correct. Yeah, Love Learning is saying it is 7. Yes, Millen is saying it is 7. So, yeah, why I was just going for searching and all. My students will say, na. Okay, so right now, let me know the answer for this question. Yeah. So this point, the distance of closest approach, okay, distance of closest approach na enna? Distance of closest approach na, definitely let us say, here we have a nucleus, another nucleus is coming, okay, here we have a nucleus, here another nucleus is coming. So definitely it is coming, this is at rest, okay, this is at rest, and this is coming with a velocity, okay, and after some time what will happen? Logically you think, what will happen? So idu vandu oru nucleus da, idu kuda oru nucleus da, okay, okay. So tell me, idukapra enna agum? So this is a nucleus, another nucleus is coming, okay. So just go for some distance, what happened, what will happen? So for whom I am explaining all those things? Yes, Susie, very good, it will repel, okay, it will repel. Yena idu kuda positive da, this is also positive. So positive comes, so definitely anga oru repulsion irukum. Correct? So appadina in the repulsion nala, there will be at some point it will come to rest. Okay va? So actually if I am saying the total kinetic energy will be converted as the potential energy. So the potential energy it will be potential energy or expression you guys already mentioned. Do you remember? Do you remember when I was asking potential energy and the time you people have given the equation? What is the potential energy or equation? K Q1 Q2 divided by R da. Correct? So I will be keeping the K value, and now you have to tell me in the first case a charge Z1 and a mass M1. Appadina what is going to be Q1? It is nothing but Z1 da, Q2 Z2 da divided by R0. Idu da nama stopping distance. Okay, or distance of closest approach. Now can you give me the answer? Yes, very good Fatima, very good Manchu, very good Susie. So what is the answer? It will be nothing but proportional to Z1, Z2. Okay, got it? Yes, option B. Stay in physics. Yes. Okay. So now let us go for the next question. Ready now? Give me a fire. Everybody give me a fire. So adikapu nadi. Okay, I forgot a topic. You guys should remind me na. Okay. So now, okay. So in the case, don't distract da. Idu vanda study pandra time da. So you just focus on what you are studying. Okay. So ipa vanda I'm just talking about the recoil of atom. So what is going to be this recoil of atom? Can you just give me an idea about what is recoil of atom? What is going to be recoil of atom? Impact parameter vanda simple oru topic da. Actually what is happening? Again, inga oru nucleus irukke. Okay. So right now another nucleus is coming. So it will be coming like this. Okay va? It will be coming and it will collide with it. So actually இதுதான் one nucleus, இதுதான் another nucleus. So இப்படிதான் it will go na. Definitely இதுதான் this is what the center irundha I will be drawing a line. So this is what the impact parameter. What you should know is this is the perpendicular distance, what you are saying, impact parameter. ANA for elastic collision, which means the head to head collision la in the impact parameter 0 da. This is what you should study in this. Okay. So now So now just understand what is recoil of nama atom. So recoil of atom na, so let us say inga oru atom irukku, okay, so inga oru electron irukku, nama valence shell illa oru electron irukku, okay. So initially idu vandu both the system vandu rest la da irukku. So before that, can you just let me know what is conservation of momentum? What do you mean by conservation of momentum? Conservation of momentum, can you just let me know what is this? Can you just please let me know? Yes. Not like that, Mukesh. So now you guys tell me what is the, yes, very good Linkeshwara. It is nothing but the initial momentum should be, okay, I'll just specify like this. The initial momentum should be equal to the final momentum. This is the conservation of momentum. Yes, the external force is 0 agumbodhu da actually the momentum conserve agapore. So right now when I'm talking about this one, so actually sollumbodhu initially in the electron, okay, in the electron is actually in a in the energy state la da irukke. Right now both the system both the electron illana the atom rest la da irukke. So I will say initially momentum 0 da. புரிஞ்சுதாடா? understood na? Give me a heart. Okay, give me a heart. So initially நம்ம total energy சொல்லும்போது, sorry, the total momentum சொல்லும்போது 0 தான். ஏனா restல தான் இருக்கு, velocity 0 ஆகும். So definitely momentum 0 ஆகும். Okay, so right now what happened? இந்த electronக்கு அந்த energy level பிடிக்கல. So it does wanted to come to the lower energy level. So lower energy level if it needs to come na, what it is supposed to do? What it's supposed to do? So இப்போ higher energy ல இருக்கிற ஒரு electronக்கு if it needs to come to the what is a lower energy level na, what it should do? What should it do? What will it do? Tell me. It will emit a photon. Very good, Susie. Okay, very good. So it has to release a photon. So it will lose some energy and it will come to the lower energy level. Understood, everybody? Are you guys getting what I'm saying? Yes, Manchu is saying 3 likes, 3 more likes. Can you guys give? Yes or no? Okay, so now what is happening? So if the electron wants to go like this now, in the photon should go like this, correct? So now I just wanted to know what is the momentum of the photon. We have already discussed in terms of lambda. Can you give me the answer for momentum of photon? What is that? The momentum of the photon is nothing but h by lambda da. So after this, when this electron is decided, okay, I wanted to go back to the lower energy level, and the time varakku momentum 0 da. Right now there is a momentum. Yena in the photon is moving in this direction. We know that initial momentum 0 aanadanaala final momentum kuda 0 aganum. Correct? Initial momentum 0 da, appadina final momentum is also supposed to be 0. So final momentathila I got this as h by lambda. Now I know that this atom should also exert some momentum to make it 0, which means if the photon is moving in this direction, the atom should go back. Okay, the electron is going down and the time in the atom should move. Yena photon is exerting some momentum, adu total momentum 0 agadam, yena initial momentum 0 da. So as we know, conservation of momentum, according to conservation of momentum, the final momentum kuda 0 aganam, and final momentum na, there is the momentum of photon plus the momentum of the atom. So when I'm talking about this one, and this should be equal to 0, so h by lambda should be equal to mass into velocity. Mass into velocity na, the momentum of the atom da. Okay, momentum of the atom da, mass into velocity. So in the velocity da, when electron is moving in this way, with this v velocity, the atom will be moving in the exact opposite direction. So now I can say h by m lambda, which is going to be the recoil velocity. The negative sign is indicating that both the photon and atom will be moving in the, again breaking, yes or no? Okay, if it is breaking, let us see. Okay, any problem? Still, is there any problem? No. Okay, fine. So appadina what will happen? We will be getting the recoil velocity as minus h divided by m lambda. So this is what the recoil of atom and recoil velocity. Can we move on to the next question? Can we go for the next question, or should we go for a break? Or you guys want a break? Yes or no? 5 minutes break. Okay, 5 minutes and all I'm not going to give. So let us just quickly go for the question. Okay. Okay. So now the orbital frequency of an electron in the hydrogen atom is proportional to orbital frequency. Orbital. One more short explanation for the atom. Okay. So simple, simple ada. So actually it is the recoil of gun. What is happening in the recoil of gun? Tell me. What is the recoil of gun? So actually it will be, when the bullet is moving forward, this will be moving backward, right? Yes, idukapram break dada, don't worry, no worries. Okay. Okay, so right now what is going on? So it will be moving forward, it will be going back. So exactly the same thing is happening over here. Instead of bullet, inga vanda photon da, and instead of gun, inga vanda we have the atom. Okay. So now we can say that the initial momentum should be equal to final momentum as per conservation of momentum. So now initial momentum since the system is at rest, we can say it will be coming as 0, and final momentum supposed to be equal to 0. Final momentum kuda it's supposed to be coming as 0. Now the thing is like, in the final momentum, the momentum produced by the photon and the atom. So the final momentum we will be having the momentum due to the atom, and we will be having the momentum due to the atom and photon. Okay, so this will be coming as mv plus h by lambda, supposed to be equal to 0 as per conservation. Okay, so now mv will be equal to minus h by lambda, v will be equal to minus h by m lambda. Purinjidada? Everybody got it? Yes or no? Yes or no? Yes or no? Now simple on a question. So you people will give me the answer, because already we know the answer. The orbital frequency of an electron. Orbital frequency, which means nama omega. We have discussed about omega, right? Do you remember this? Do you remember this? Omega. Omega, time period and omega is inversely proportional, and we have discussed about all those things. Please, everybody. Thank you, Zusi. Thank you. Yes, this we have already discussed. Please just check and let me know. Very good, very good. We will be getting n to the power minus 3 da. Okay. So now let us go for one thing da. Let us just go for a 15 minutes of break. I will add few more questions also. Okay. Dual nature la we need to do few more questions. So let us see da. So let me just take a 15 minutes of break. Yena vandu in the slide la paakumbodhu, because as I mentioned, no, idu vandu enakku kuda oru refreshing task da. So I felt like there will be more questions, and I vandu konjam questions missing airike. So I will add more questions, and I will be just continue in the next after or 15 minutes kapram I will be starting the lecture. Okay, so let us just do the resume at, okay, resume at what time you want? 15 minutes is okay, right? Yes or no? So we will be resume at 6:45 p.m. Is it fine for everybody? Okay. So nama like ku kuda target irukenda, like target. Okay, nama like oda target vandu 200 plus. Let's see. Okay, so yes, class முடிஞ்சதுக்கு அப்புறம் you will get it. Okay, in the comment box இல்ல description box இல்ல class PDF வந்து available இருக்கும். Okay, so அது வந்து I cannot say, okay, நீங்க வந்து you have to practice in the last 5 years இல்ல 10 years. If முடிஞ்சனா the last 30 years question paper கூட you can do it. No worries on it. அவ்ளோ if you are doing na அவ்ளோ confidence you will get. Okay, so as per your timing. Okay, so இப்போ வந்து concept வந்து you need to focus இல்ல you need to focus on the what to say questions that is depending upon you. Concept clear na, you just start solving the questions. You can use any of the materials, anything is fine. Okay, So see you guys. We will meet at 6:45. Okay. So by the time I will add some questions and I will come. Okay. Thank you. Everybody is here? Give me a fire if you guys are here. Everybody give me a fire. I'm Swati, new joining. Have you enrolled into the RE-NEET crash course? It is a free crash course. You can just join. You can see the description box. Nama first link it is talking about that only. I can hear you, ma'am. Thank you. Okay, yes. Sanchu is writing fire. Waiting for a long time. Oh my god. Okay, Harish. Okay, now I'm here, right? So guys, don't forget to like the session. Everyone should like the session. And now we are going for the another question. I'm new to this channel. Yes, Sharu, you can also join into the RE-NEET crash course. Okay, it is very useful. So you can just enroll it. There are a lot of features like offline centers, how we will be getting the okay, so the answer is already visible, but you guys have to do it. Okay, so right now the energy required to remove the electron from a simply ionized helium atom is 2.2 times the energy required to remove an electron from the helium atom. Okay, so right now I can just write the relation. Okay, I can write the relation. What is the relation? What it is mentioned, the energy required to remove the electron from a simply ionized helium atom is 2.2 times the energy required to remove an electron from the helium atom. So I'll be just mark, okay, here 1 and this is at E2. Okay, so this is the first relation, we got it. Thank you, Pranati, right? Thank you so much. Okay, so right now we are going for the mixed dual nature. No problem. You can just continue with the atom question practice. So adikapram we will be going for nuclei. Adikapram you can just, once the session is entered, you can go back and you can watch it. Okay, so this is what the first thing. Now the thing is like you can find E2 simply. Okay, you can find E2. Okay, how we will be finding E2? E2 வந்து E1 by 2.2 தான். How we will be finding E1? E1 வந்து find பண்றதுக்கு நம்ம எனர்ஜியோட relation minus 13.6 Z square divided by N square. So Z னா இது வந்து helium இல்லடா. So Z வந்து 2 ஆ இருக்கும் and N வந்து it is actually removing from the it is not mentioned about the state, so you can just take it as 1. So now helium atom, so I can just go for minus 13.6 Z square na 2 square divided by 1 square. Can you find the answer? Can you find the answer for it? Can you find the answer for it? What is going to be the answer? This is the energy expression minus 13.6 Z square by N square electron volt. Now you can find E1 value. Once you got it E1, then you can substitute for E2 because E2 will be, from here you will be getting E2, which is nothing but E1 divided by 2.2. So if you got the value of E1, you can go for the answer. Okay, already everybody is giving the answer because it is visible. Now I want, that is what I am asking, step by step solution. So tell me what is E1. I want E1. I don't want answer one thing enake theriyunda B da. So now you tell what is the answer for E1. That is what? Yes, very good Mukesh. It will be coming as 54.4 electron volt. Now this will be coming as 54.4 electron volt divided by 2.2. So you will be getting E2 as well. Now what is the next step? Just add E1 plus E2. You will be getting the total energy. Okay. So while you are doing E1 plus E2, you will be getting 79 electron volt as the answer for this question. Purinchidada? Everybody give me a heart if you understood. Everybody give me a heart if you guys understood this one. I want more hearts. Vishwa, I think you are new to this class, right? Yes. Yes. So now we will be going for the next question. So in the next question, okay, the electron in a hydrogen atom first jumps from the third excited state to the second excited state and subsequently to the first excited. Oh my god, I lost the contact. Okay, so the electron in a hydrogen atom first jumps from the third excited state. Third excited state சொல்லும்போது n is equal to 4. Okay, so initial வந்து actually வந்து 4 தான். அதுக்கப்புறம் what is happening, jump from the third excited to the second excited state, which means n will be equal to 3 தான். Okay va, and then to the first excited state, which means n is equal to 2. Okay, the ratio of the respective wavelength, we know the equation, இது வந்து hydrogen atom, right? So 1 by lambda, which is equal to நம்ம Rydberg constant into 1 by ni square minus 1 by nf square. Okay, so you have to find the lambda for the ratio of the respective wavelength that we need it. What is asked? Lambda 1 by lambda 2. So first of all, I'm going for 1 by lambda 2. Okay, yena 1 by lambda 2 divided by 1 by lambda 1 will be giving me what? Will be giving me lambda 1 by lambda 2. Till this understood? Please give me a heart, everybody. Everybody give me a heart. 1 by lambda 2 divided by 1 by lambda I will do. So I'll be getting lambda 1 by lambda 2. Okay, so now the thing is like what is 1 by lambda 2? Okay, I have to consider the second part, which means in the 3 irundhu 2. Okay, in the 3 energy level 3 irundhu we will be jumping, or the electron is jumping to 2. Correct? So I'm just going to substitute that. Rydberg constant anyway it will be get cancelled. So 1 by ni சொல்லும்போது initial energy state na 3 square minus 1 by 2 square divided by again Rydberg constant into 1 by initial state na 4 square minus 1 divided by 3 square. So this is what you need to do. R will be get cancelled. Now you can just simplify this and you can just give me the answer. Can you give me the answer, everybody? And guys, those who are new to this channel, marakama subscribe panniko. Also you guys have to what to say, nama re-NEET crash course, free crash course la join panniko. Description box la link irukku. Just you need to go for buy now, lots of features, unlimited features. That is what the advantage. So what is the answer? C. Check again, check again, everybody. Everybody check and let me know. Do the calculation. So inga vandu paakumbodhu this will be coming as 1 by 9 minus 1 by 4, and here it will be coming as 1 by 16 minus 1 by 9. Okay. So you will be getting option A as the answer. Okay, you will be getting the answer option A. Now let us go for the next question. Okay, so in a simple question we can just handle. Okay, so energy levels. Okay, energy levels. Very good Preeti, very good Sanju. Okay, Hari Prasad, very good. So loga again 1 more hour, hardly 1 more hour. Energy levels A, B, C of a certain atom correspond to increasing values of energy. EA is less than EB, less than EZ. Lambda 1, lambda 2, lambda 3 are the wavelength of the radiations corresponding to the transition from Z to B, then B to A and C to A respectively. Which one of the following is correct? This is the question. So in the question we need to find the relation connecting this wavelength. Correct? We know that nama energy vandu sollumbodhu, the photon oda energy vandu sollumbodhu, it is nothing but hc by lambda da. Correct? So if I'm just considering from C to A, okay, so energy released when it is jumping from C to A, it will be EZ minus EA da. Can I say that this will be also equal to EC minus EB, okay, plus EB minus EA? Can I say this, yes or no? If you are okay with it, give me a heart. Everybody give me a heart. Not option A, not option A. Don't just give me the answer. Okay. Okay. So now please Right now, you can just go for this. Energy na hc by lambda da. So my question is, when it is jumping from C to A, okay, when it is jumping from C to A, the energy will be equal to the energy which is released when C to B and then B to A. And the time la irukra energy da vanda, what is it, the sum will be, 1 second guys, 1 second, give me a minute. Okay, so yes, so now this is what the equation we have. Now we can just write the equation for these cases. Okay, so when I'm talking about EC minus EA, okay, in the energy level when it is jumping to A, what is going to be the answer? What is going to be the answer? EC to EA. So it will be coming as HC divided by the wavelength on the lambda 3 da, which is equal to what I said, the energy released from C to B, which means HC by lambda 1 plus HC divided by lambda 2. Everybody understood? Everybody understood? Everybody understood, yes or no? Are you guys getting it? Yes or no? Please respond, yeah. Can you get, are you guys getting it? Till this understood, now give me a heart. Everybody. I want to distract myself, please. I need your support. Yes, 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 yes. Okay, fine. So, now the thing is like HC is common in both the cases. Now, I am going to take this 1 divided by lambda 3, which is equal to 1 divided by lambda 2 plus 1 divided by lambda 1. So, now you can just take it. Lambda 3 will be coming as cross multiplication. You will be getting lambda 2 divided by lambda 1 plus lambda 2. Okay, so this is going to be the answer for it. Understood everybody? Yes or no? Yes or no? So what is going to be the answer? What is going to be the answer for this question? What is going to be the answer for this question? And guys, don't forget to like the session. Don't forget to like the session. Very good. We will be getting lambda 3, which is equal to lambda 1, lambda 2 divided by lambda 1 plus lambda 2. Very good. So now we are going for the next question. Okay. Yeah. Now you can just go for this question. What is written over there? What is written over there? Okay. When a photon is emitted by hydrogen atom, the photon carries a momentum with it, and the hydrogen atom emits light of wavelength 660 nanometer. With the speed does the atom recoil. So recoil speed that we needed. What was the equation? Do you remember the equation? Can you just please let me know what is the equation? Recoil velocity or equation? Everybody quickly give me the answer. You guys have already studied this. You guys have already studied this. Give me the answer for this one. What is the answer? H divided by lambda into m da vanda nama answer aga porom. So lambda, which means we have given 600 into 10 to the power minus 9 da, and m value vanda nama electron oda mass da, which is nothing but 1.6 into 10 to the power minus 27. Okay, nama hydrogen atomoda mass, it is 1.6 into 10 to the power minus 27. Very good, very good. So now 6.6 into 10 to the power minus 34 divided by 660 into 10 to the power minus 9 into 1.6 into 10 to the power minus 27. So can you give me the answer for this question now? Everybody? Okay. What is the answer? We will be getting the answer as option A, 0.6 meter per second. Yes, Amiksha, very good, very good, very good. Okay. Yes. So now let us just quickly go for nuclei. Adukapram, once we have done with the concept revision, adukapram I will be again adding some PDF. Adukapram we can just do more questions. Will it be okay for everybody? Okay. So questions vanda we are not stopping. Right now we are quickly going for nuclei. Adula vanda konjam simpla we will be explain everything. Okay. Adukapram we will be going for the question practice. Will it be okay? Will it be okay for everybody? Give me a yellow heart if it is okay for you people. Give me a yellow heart if you guys are okay with it. Yes, yes, okay, fine. Because now I was thought like there are many questions in this, but the problem is like there is no much questions. So I felt like I can add more questions, so I have made it. So the kapram I will add here. Otherwise this note will be shuffled. I don't want that to happen. Okay, yes. So in the IPL who is playing da? Miss CSK va? Who is playing? 7:30 ki thana starting. CSK. Oh my god, oh my god, oh my god. We are going to miss that, right? Okay. Or you will miss me and you will go. What will happen? Huh? Yes. So now we are going for the nuclei. So in the nuclei, first one you should understand. Yes, I know that many CSK fans are here. But definitely don't forget me. Don't leave me here and don't go behind CSK. Okay. Right now, I mean anybody will just go and check the points and they will inform here. That's enough. Okay. So I'll just continue till 8:15 at least. 8:15. Okay. Is it fine? Yes, thank you Fatima, thank you Manju, thank you. I have my people. Okay, so right now RCB assemble here. Bye Dora Mama. Why da? It is at 7:30. Oh my god, everybody was forgot about this and I am the one who reminded about it. Okay, this is too much, yeah, this is too much. Okay, so now we are going for the nuclei chapter. Okay, so nuclei chapter la first one we are going for how to represent us. Okay, my favorite team is always CSK. Oh my god, CSK first batting. Okay, I mean just give some updates if you're going. But you should watch this lecture also. We don't have much time. As a teacher, I should say you people should be here. Okay, and when someone is getting updates now, you can just give the updates. That's it. Don't go completely behind it. Okay, Namma Chetan is there, no, that is what making me so. But till 7:30 you can stay here. Don't say bye right now. Okay, so now we are going to discuss about the nuclei. So in the nuclei we know that we have to represent a nuclei like this. Here we will be having the mass number. Here we will be having the atomic number. Z na atomic number da. A na it is coming as the mass number. Okay, so right now the thing is like we know that when I'm talking about Z atomic number, it is actually equal to number of electrons, which is actually equal to number of protons. Correct? When I'm talking about mass number, can you give me the relation? Can you give me the relation? What is going to be mass number? How we can just relate it with? We know that it is nothing but the number of protons plus the number of neutrons, which means Z plus the number of neutrons, or let's say we can again write number of electrons plus number of neutrons. Z is equal to Np is equal to Ne da. So we can just find this relation. Very good, very good, very good. Guys, don't forget to like the session, everybody. So this is how we will be representing a nucleus. Next one is we know that when we are talking about the nucleus, we know this A minus Z da, number of neutrons it is nothing but A minus Z da. Next one the nucleus oda size da. When I'm talking about nucleus oda size, it is actually proportional to 8 to the power 1 by 3, which means mass number raised to 1 by 3 da actually vanda nama radius. Okay, illana nama size of the nucleus vanda represent pandrathu. So appadina what will happen in the R vanda proportional to 8 to the power 1 by 3. So adukku vanda oru constant value தேவையா இருக்கு to make it to equality. அதுக்காக I'm going to introduce a constant value which is R naught. So you can just go for, okay, R naught, okay, 1.1 into 10 to the power minus 15. இதெல்லாமே வந்து easier remember பண்றதுக்கு difficult இருக்கும்ல. So you can just go for 1 femtometer. Okay, femtona it is 10 to the power minus 15. So R naught oda value, even if you are multiplying it with 1.1 or 1, it is going to be almost same. So you can just keep this R naught value as 10 to the power minus 15, as the answer. Okay. Isotope, isobar, it is not mentioned in the syllabus da. Okay, if you want you can, once you are getting extra time na, you just study this. Now the thing is like about the density. Density வந்து constant da. For ஒவ்வொரு nucleusக்குமே வந்து இந்த density constant da. It is not depending upon the mass number. Many times இது வந்து statement based they have asked. Okay, so எப்பவுமே இந்த density வந்து density ஓட value வந்து it is independent of the mass number da. Correct ah, புரிஞ்சுதாடா? Can you give me a heart quickly everybody? Everybody, can you give me a heart quickly? So the density of the value வந்து it is coming as approximately 10 to the power 17 kilogram meter per second, and in the value will be, it is independent of the, what to say nama, this one. Next one வந்து நம்ம 1 AMU. What is this 1 AMU? In the value வந்து you have to study. Okay, so இப்போ வந்து whenever we are talking about the mass of these what to say the nucleus and everything, it is very 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 small. So அது வந்து we need to, எல்லாத்துக்குமே வந்து for everything we should find something which is easier, right? So usually வந்து இதோட mass எல்லாமே வந்து we will say in terms of AMU, and 1 AMU which is equal to 1.66 into 10 to the power minus 27. 1 AMU ஓட value da, it is also also equal to 1 by 12th of the carbon 12 atom. Okay, so this is almost close to the electron. Electron oda mass இது வந்து same, almost equal da. Okay, so 1 AMU value வந்து you should study. Even you have already studied in the, what to say, chemistry la kuda you know this AMU and everything, you are studying this, so it is not a big deal. Next வந்து நம்ம energy, நம்ம Einstein ஓட energy relation da. Energy relation சொல்லும்போது we know that mc square, which means mass can be converted as energy. So when I'm talking about, okay, இப்போ வந்து energy is equal to mc square da. When I'm talking about the nucleus, in the nucleus kulla, what are the things here da? In the nucleus kulla, who will be there in the nucleus? In the nucleus kulla, who will be there? Okay, afternoon only you have studied everything. Oh my god, then I don't need to teach, right? So in the nucleus kulla we can see protons irukum, neutrons irukum. Correct? So the nucleus order, if I'm finding the mass of the nucleus na, it should be equal to mass of the protons, which means the total mass of the protons, which means one proton is having a mass mp. Appadina total number of protons, which means np. Okay, it should be equal to mn and nn. Correct? Are you guys getting it? Are you guys getting it? Thank you Sanchu, thank you so much, thank you so much. So இப்போ வந்து mass of the nucleus பார்த்தேனா அதுக்குள்ள neutron இருக்கு, proton இருக்கு. So total mass of the proton, total mass of the electron வந்து total mass of the neutron calculate பண்ணிட்டேனா that should be the mass of the nucleus. Okay va? So when I'm talking about total mass of proton, one proton oda mass வந்து mp da, அந்த மாதிரி n number of particles இருக்கு. So this mass will be like this, and this is what the neutron oda mass. அப்படினா when we are checking, this is not equal. Okay, this is not equal. Why this is not equal? So ingayavathu some energy is actually wasted or it is utilized for some other purpose. And the time la da inda or equation ku relevance irukku. In the mass is actually converted as energy. Edukku in the mass is actually converted as energy? Yena in the in the neutrons and protons should hold together, right? We need to keep them together. And adukkaga it needs to exert some energy or it needs to give some energy. And the energy da actually vandu we are calling it as the binding energy. Bind pandradhukku, okay, to keep everything together it has to give some energy. Adha vandu binding energy. In the binding energy is coming from where? It is coming from this mass defect. Mass defect na enna? Mass of the total particles, okay, mass of the neutron plus proton minus the mass of the nucleus this is what the mass defect delta m. In the delta m is actually converted as the binding energy. So I'll be replacing this equation as delta m c square. Understood everybody? Understood everybody? Please let me know. Please let me know. 15 more minutes. Binding energy which is equal to delta m c square. Okay. So now the thing is like I should write what is this delta m and what is z delta m? Delta m na nama mass of the total mass of the neutrons plus total mass of the protons minus mass of the nucleus. Now you tell me what is the mass of neutrons? What is the mass of neutrons? Neutrons sollumbodhu definitely adoda mass vandu I am writing it as mn. And how many number of neutrons irukku? We already discussed about this thing. What is the value? It is nothing but the mass number minus atomic number. Now, mass of one proton is mp. What is the number of protons? Can you give me the answer in the chat box? Very good, Preeti. So it is coming as ZMP minus mass of the nucleus. This is what the equation for delta m. This is what the equation for delta m, number mass defect. A minus Z mn plus ZMP minus mass of the nucleus. Purinjidada everybody? And this into C square if you are doing now, you will be getting the equivalent energy of it. So let us say, I have told you, okay, in the delta m oda value vandu 1 AMU da. Okay, inga irukra mass defect oda value vandu 1 AMU da. Okay, mass defect vandu 1 AMU da. Appadina, if let us say 1 AMU na, you should get the energy. Can you just give me the answer for this question? Mn na, what is the mass of neutron? Okay, mass of neutron da Mn, Mp na mass of proton. So, இப்போ வந்து 1 AMU தான் நம்ம defect இருக்கு இல்லனா mass defect na 1 AMU தான் அதுக்கு equivalent ஆன energy. What is going to be அதுக்கு equivalent ஆன energy? It will be coming as delta m c square, which means 1 AMU into c square. So, this one, I mean, if you are finding this, you will be getting அதுக்கு equivalent ஆன energy வந்து 931.5 mega electron volt. Very good, Fatima. It will be 931.5 mega electron volt. You should study this one. Sometimes they will say the total what is a mass defect வந்து 2 AMU da. Appadina you should say 2 into 931.5 mega electron volt is going to be the total what is a binding energy. Purinjidada everybody? Are you guys getting it? Are you guys getting it? Fine. Even I didn't notice, huh? What happened? Let me check. Yeah. So this is what the answer. Voice breaking still. Currently, we can't do anything da today because idu vandu replace pananum. Adu vandu nalikku da possible ah irukum. So that was the problem. Because inneke I think I did something. Chemistry class la cracking edu irundella. There is no cracking in the chemistry class, right? So I only did it. I should accept this. Okay, so this is what the thing. Okay, this is what the thing. So these are the things you have to study. Now nuclear fission and fusion. So the one important ana. Okay, and again when we are talking about stability, we know that when in the binding energy per nucleon is very high na, they hold it together tightly. Okay, they hold it together tightly. So it will be very difficult for someone to take one particle from there. So binding energy per what is a nucleon is more na, definitely that is indicating more stable. So more stable, which means nama iron da. So always nama lesser mass number irukra particles vanda less stable da. Also if the mass number is very high nalum avanga vanda they will be what is unstable da. So now you have to tell me what is fission and fusion. Yena nama lower energy illana lower atomic mass number irukra particles ellame vanda to come to stable state, because everybody wants to be in the stable state, correct? I mean, we also wanted to become in the stable state, correct? So appadina definitely in the lower mass number irukra particles or nucleus will come together and they will fuse and they will come to a what to say, higher, or let's say the stable state. Idha we are calling it as fusion. Fuse together and we will come to the what to say, stable state. And higher mass number irukra particles avanga heavy irukke, right? Heavy nucleus da. Ivanga what they will do? They will split and they will come to the stable state. So in the splitting process da actually nama nuclear fission. So the properties ellame I have written, so you guys have to go through it. Okay, this is what the fission and fusion. So idhula what to say, when I'm talking about energy, too much energy will be released from the nuclear fusion. This is what is happening in the sun and everything. Okay, sun is burning and this is the what to say, process which is happening in the sun. Okay, so these are the things which we need to study in the nucleus chapter. Now we are going for the first question. So you can just give me the answer for the first question. You can give me the answer for the first question. Okay, so let us do this. So what is happening here? What is happening? A nucleus has a mass number alpha and a radius r alpha. Another nucleus has a mass number beta and radius r beta. Okay, and beta and alpha relation is also given. We need to find the relation. Okay, r alpha divided by r beta da nama find pannanom. We know that r naught into in the alpha oda mass number raised to 1 by 3 divided by r naught into in the beta order raised to 1 by 3. R naught will be get cancelled. Now alpha and beta order relation they have given. Correct? So now we can say that alpha by beta, okay, alpha by beta all to the power 1 by 3. So now tell me what is the relation alpha and beta? It is given beta is nothing but 8 alpha raised to 1 by 3. So now we will be getting 1 by 8 all to the power 1 by 3. I'm rewriting this 2 raised to 1 by 3. Sorry, 8 raised to 1 by 3. Sorry, 2 cube. Okay, 2 cube da actually 8. So 1 by 3. Now can you find the answer for this question? Can you find the answer for this question? Yes, I can see the right answers. Very good. So we will be getting 0.5 as the answer. Yeah, 1 by 2 cube raised to all to the power 1 by 3, which means I'll be getting 1 divided by 2 to the power 3 into 1 by 3. So this will be get cancelled and I'll be getting 1 by 2, which means 0.5. Understood? Now give me a red heart, everybody. Give me a red heart, everybody. Everybody give me a red heart. Yes. So now let us move on to the next question. Okay. So in the question, two electrons are moving in orbit of two hydrogen-like atoms with the speed 3 into 10 to the power 5 meter per second. Okay, we have two electrons are moving in orbits of two hydrogen-like atoms with the speeds 3 into 10 to the power 5 meter per second and 2.5 into 10 to the power 5 meter per second. If the radii of these orbits are nearly the same, radius is almost equal. What is the possible order of energy state? Okay, we need to know what is N1 by N2. Or let's say N1 and N2. We need to find it. So, first you should tell me what is the radius order relation we have Z. What about the radius order relation? Radius, I have told you 0.53 into n square by z. So I can say that r is proportional to n square by z. Correct? So now can I write n1 square divided by z1, which is equal to n2 square divided by z2. Yeah, they have given that, what they have given? They have given the radii is almost equal. Am I right or wrong? Tell me everybody. Am I right or wrong? Yes or no? Till this understood, give me a red heart. Till this understood, na, give me a red heart, everybody. So right now I'm talking about the radii da. So radii is proportional to n square by z da. So appadina n1 square by z1 will be equal to n2 square divided by z2. So idilarunda I'm going to find the expression for z1 by z2. Okay, which will be coming as n1 square divided by n2 square. Idudha vandu nama first relation. First relation, z1 divided by z2 will be coming as n1 divided by n2 the whole square. Now we know the speed. Okay, speed order relation. Okay, in the Madri radius when we are considering, we know the speed will be equal to, or let's say proportional to z by n. So when I'm talking about velocity, some constant is there. Now I'm not worried about it. Some constant, let me just say k. Okay, which is k into z1 divided by n1. This is what v1. Now v2, which is equal to k into z2 divided by n2. Till this understood, everybody? Yes or no? Yes or no? Please let me know da. Till this understood. In the velocity we have found a relation, right? When we were discussing the atom. And the time I have told you, the velocity order relation, na, it will be connecting with k, some constant into, illana adu vandu proportional to z1 by n1 da. Now I'm going to do one thing. I'm just going for v1 by v2. So what I will be getting, z1 by n1 and n2 by z2. Okay, so now z1 by z2, n2 by n1, just I have rearranged. But ana in the z1 by z2 expression already I have found it. What is the z1 by z2? It is nothing but n1 square divided by n2 square da. So inga kuda n2 by n1 irukke. So this will be get cancelled, this will be get cancelled, and finally v1 by v2 I will be get it as what? n1 by n2. Till this understood? Any confusion? Any confusion? Anybody is having any confusion? Please let me know. Please let me know. Right? So what is the next step? We need to know n1 by n2. Correct? Adikaga already they have given v1. v1 is 3 into 10 to the power 5 da. v2 na 2.5 into 10 to the power 5 da. Now it is your answer. You can just go for it. Find the answer and tell me what is going to be the final answer. What is going to be the final answer? Very good, very good, very good. I'm getting the right answers. Very good. So we will be getting option D as the right answer. Can we go for the next question? Ready na, give me a fire. Everybody, ready na, give me a fire. I want more fires. I want more fires. Okay, can we go for it? Yes. Yes, this question. Okay, so you guys can do it. Just give me some 2 minutes. Okay, so now let us go for this question. The minimum frequency of photon required to break a particle of mass 15.348 AMU into 4 alpha particles. So this is what the question. So now the thing is like the mass of the nucleus is given, 1 AMU value is given, H is given, and C value is also given. We need the frequency. So when I'm talking about frequency, how could I find frequency? Can I say this is nothing but E by H? Energy is equal to H mu da. So can I say that E by H da nama frequency? Can I say this? Yes or no? Yes or no? So we should find this energy. Energy na, it is nothing but delta m c square. C square part is not at all a problem. Right now the thing is like you have to find this delta m. So how you will be finding delta m? So delta m na nama mass, final mass sollumbodhu nama heliumthoda ena alpha particle 4 alpha na, it is representing a helium, it is like a helium atom, right? So you can just find 4 into in the value 4.002 AMU. Okay, this is what the final mass. We need to convert 4 alpha. So 4 into this value minus what is the other mass? Yes, 15.348 AMU. So this is what the delta m value. Now you have to multiply it with C square. So you will be getting the energy. Once you get the energy, you can just divide it with, okay, delta m c square divide with nama H value. H value is also given in the question. Can you find the answer for this question? Everybody? Can you find the answer? And we need in kilohertz. So while we are calculating the final answer, you have to be careful about the unit. We will be getting delta m as 0.66 AMU. Okay, 0.66 AMU. So this into 3 into 10 to the power 8 whole square, which means 9 into 10 to the power 16. And we need to convert this into AMU, you need to convert also. Okay, 0.66 into 1 AMU na 1.66 into 10 to the power minus 27. I'll write here. Okay, so this is what the delta m. This delta m you can just substitute here and multiply it with C square. Check it again, da. Check it again. Hajir. Check it again. 0.66 into 1.66 into 10 to the power minus 27 into 9 into 10 to the power 16 divided by 6.6 into 10 to the power minus 34. Check again, da. Calculation error. Power mistake, yes. So we will be getting option D as the answer. Okay, we will be getting 14.94 into 10 to the power 19 kilohertz da nama answer varaporum. Okay, so delta m vandu 0.66 AMU. Okay, adukapram we have converted into the what is AMU to kilogram, we have converted into 9 into 10 to the power 16. You will be getting a value and that value divided by 6 into 10 to the power minus 34. Okay, let us go for the next question. Okay, so what is happening here? In an alpha particle with energy 7.7 mega electron volt is bombarded with a thin gold foil, the closest distance from the nucleus it can reach is. So when I'm talking about the closest distance, we know that the energy which is equal to K into Q1 Q2 divided by R naught da. We need this distance, right? We need the closest distance of approach, which means K Q1 Q2 divided by E. This is what going to be the equation. Now the turn is like you should know what is K. What is K? It is nothing but 7.7 mega electron volt, which is already given in the question. 7.7 mega electron volt da. So now I can say that 7.7 into mega, which means 10 to the power 6 into electron volt na 1.6 into 10 to the power minus 19 da. Till this understood, everybody? Till this understood? Till this? Live and both premiere. What is premiering? What is premiering? No premieres at all. Don't say anything. Okay, so this is what the energy you will be getting. Now you can just, K value we already know. What is the K value? Do you remember? Electrostatic potential energy. Do you remember that? Are you guys remember the equation? Do you guys remember? Atomic number is also given. So K value is nothing but 9 into 10 to the power, okay, 9 into 10 to the power 9 da, then Q1, Q2. So charge we can say that charge of the atom will be coming as the atomic number into the electron, the charge of electron. So it will be coming as Z1, which means first case la nama Z1. It is coming as 79 into E value, so there will be 2, we can just go for 158, we have to multiply, right, into E square, which means 1.6 into 10 to the power minus 19 the whole square. In the value varumbodhu, it will be KZ1E, Z2E, okay, divided by R0. Z1 na it will be 79, Z2 na it will be coming as 2. Got it? Okay, gold and alpha particle da. So Z1, Z2, we will be substituting the value E square 1.6 into 10 to the power minus 19 the whole square, and this is the values you have to do. Everybody understood how to do it? Please let me know. If you understood how to do na, please give me a red heart. Please give me a red heart, everybody. If you understood how to do it. Yes, very good. So what is going to be the answer? What is going to be the answer? Thank you guys, thank you so much. What is the answer? Very good. So we will be getting option C as the answer. Very good, Durga. Very good. And Deva, right? Yes, very good, Deva. So now we are moving on to the next question. So in the question, energy released when two deuterons fuse to form a helium nucleus. Okay. Binding energy per nucleon for helium is given. Binding energy per nucleon for helium is actually given as 7 mega electron volt. Okay. So now the deuteron, okay, we have the energy that is nothing but 1.1, correct? The energy vandu 1.1 electron volt da. So in the deuteron paakumbodhu adula vandu paathena 2 nucleons irukku. Okay, 2 nucleons irukku. So one deuteron, okay, one deuteron will be having 2 nucleons. So the energy will be coming as 2.2 mega electron volt. Yena one nucleon have, this is energy per nucleon da. So one nucleon will exert 1.1. Appadina 2 nucleons will be there. So it will become 2.2 mega electron volt. Understood till? Give me a red heart, everybody. Yes or no? So the thing is like, just observe the question. Energy released when 2 deuterons. So forget about 2 deuterons. Now I am focusing on 1 deuteron. Adla vantha per nucleon, it will be having a binding energy 1.1 mega electron volt. Now the thing is like, we have 2 nucleons in it. ஒரு deuteronல 2 nucleons இருக்கு. So அதனால 1 deuteron will have a binding energy 2.2 mega electron volt. Okay. Yes guys, smash the like button. Okay. So now in the madri we have 2 deuterons, right? 2 deuterons is there. So the total binding energy will be 4.4 mega electron volt. This is what the first part. Okay, this is what the first part. So this is what the binding energy, okay, binding energy of the reactants. Okay, binding energy. Yena idha vanda fuse aga porum. So this is what the reactants, binding energy of the reactants. Now what is happening? What is happening after that? What is happening after that? It form a helium nucleus. Okay, helium nucleus na adukulla 4 nucleons irukkum. Okay, one nucleon is having a binding energy 7. Okay, appadina 4 nucleons irukke. So adinala I will be getting 7.7 mega electron, sorry, 7 mega electron volt into 4 the nama binding energy of the product. Binding energy of the product. Yena 2 deuterons will combine and it will give you a 1 helium. So definitely this is going to be the binding energy of product. And what is the question? Energy released, which means nama Q value da. So Q value is nothing but binding energy of the product minus binding energy of the reactants. So you can just find this value. So this will be 28 and that will be 4.4. So 28 minus 4.4 will be giving you the answer. Can you give me the answer now? Can you give me the answer now? Yes or no? Very good, very good, very good. We will be getting option C as the right answer. Okay, can we go for the next question? Are you guys ready? Yes or no? Give me a fire if you are ready. Even if you are not giving fire also, I will go for the next question. But if I am getting a fire, I will become more happy. Okay, so assuming the validity of Bohr's atomic model for hydrogen-like ions, the radius of lithium 2 plus ion is in its ground state is given by, okay, so this is actually the radius da, okay, radius of the lithium is given that R0 into 8 to the power 1 by 3 da, correct? So appadina this is given as 1 by x into A0. This is what is given. Now the thing is like you should find what is the value of x. This is what the question. So now we know that whenever we are finding, okay, not this expression, we can go for the radius of the nth orbit. Okay, so I mean anga vandu oru constant irukke. So let me just write k as the constant. We know 0.53 Armstrong da, so let it be, I'm just writing k. Okay, so Rn will be equal to n square by z. Do you remember this relation? The nth orbital order radius vandu proportional to n square by z da. Correct? So now in the case like n value enna edachu mention pannirukka, which state it is, it is nothing but on the ground state. Ground state na nama value vandu n oda value vandu 1 da. Lithium-oda atomic number என்னடா? Lithium-oda atomic number என்ன? Lithium-oda atomic number. Lithium-oda atomic number. Lithium-oda atomic number. Lithium-oda atomic number. Everybody. 3 da. So we will be substituting here some constant value. Let me just put it as A0 because there is also an A0 is there. So they are taking A0 as the this one, and n square na 1 square it will be 1, z na 3. So this when I am comparing with this one, I will be getting the expression for x as 3. Okay, correct? So yes, x will be 3. Got it everybody? Yes or no? Give me a red heart if you understood. Very good, very good. We will be getting option D as the answer. Now let us go for the next question. Yes, another question. The ratio of mass densities of nuclei, calcium and oxygen. Simply give me the answer. No need to even think about it. You can give me the answer. What is the answer? What is the answer? Quickly give me the answer. Yes, very good. Samiksha, Abhinesh, very good. So the answer will be 1. What is the reason? What is the reason? Yena nama density vandu oru constant value da. It is not going to depend upon the mass number. So this is a constant value. So if you am taking the ratio, it will be coming as 1. Purinjidada? Everybody got it? Yes or no? Yes or no? So now another question. The mass defect in a nuclear reaction is 0.05%. What is the amount of energy liberated? So energy we know that it is delta mc square da. Okay, it is nothing but delta mc square da. Guys, don't forget to like the session. Don't forget to like the session. Yes, thank you Manju. Thank you. Okay, so we are actually at a same wavelength. The same time when I was saying, Manchu's also mentioned the same thing. Very good. So now it is about the delta M. What they have mentioned, 0.05% of 1 kg. So delta M is nothing but 0.0% of 1 kg. So what is going to be this value? What is going to be this value? This is nothing but 5 into 10 to the power minus 4 kg. So now it is the turn, you can just substitute 5 into 10 to the power minus 4 into 3 into 10 to the power 8 the whole square, which means 9 into 10 to the power 16. Tell me what is going to be the answer? Tell me what is going to be the answer. Quickly you can give me the answer. Everybody. Very good, very good. We will be getting option B as the answer. Very good. Abhinesh, Fatima, Marunmani, Sanju, sorry, Marunmani has given the wrong answer. Okay, Sanju, Samiksha, Jahi, Jia, very good Hajar. Yes, very good, very good. So now the answer we got it. Now let us move on to the next question. In the question will take a lot of time for calculation. Okay, so let us do the calculation. Okay, I'll ask you to do this one, and I'll just take some water and I will come. Okay, obtain the binding energy of a nitrogen nucleus in mega electron volt. Binding energy da venum. Binding energy oda equation enada? It is nothing but delta mc square da. Okay, and MP value is given, Mn value is given, M mass of the nucleus is also given. So first of all, we should find what is this delta M. So first the task is finding the delta M da. So while I am finding delta M, first one I know it. Okay, mass of the proton into what is in the atomic number plus mass of the neutron into the number of neutron, which is A minus Z, minus mass of the nucleus. Correct? So idhula vandu paathena, what is the Z value? Nitrogen, what is the Z value? Tell me everybody, what is the Z value? What is the Z value? Z value is nothing but 7 for nitrogen. Mass of proton 1.00783. Okay, AMU plus what is A minus Z? 14 minus 7, again 7 da. Okay, mass of neutron, which is 1.00867. Then minus 14.00307. This is what the delta M. Once you got the delta M, you can multiply it with 9 into 10 to the power 6, which will give you the answer. Okay, so can you find the answer? Meanwhile, I'll take some water and I will come. Okay, it may take some time for the calculation, but you should. Okay, adukku munnadi answer you are giving. Nobody is doing the calculation. Okay, so just give me 2 minutes, I will take water and I will come. So everybody got the answer? Okay, so now let me add some more questions and then we can just again continue. The answer will be option A. The answer will be option A. Very good. Okay, so let us continue. And guys, don't forget to like the session. We are going for the another set of questions. Okay, we can just do some more questions and we can just wind up this session. Okay. So simple another question. You can give me the answer quickly. Okay, so what is the question? The total energy of an electron in an atom in an orbit is minus 3.4 electron volt. Its kinetic and potential energies are respectively. This is the question, kinetic energy and potential energy. We already know the relation. What is the kinetic energy and potential energy? Kinetic energy is proportional to, equal to minus total energy. Kinetic energy is equal to minus potential energy by 2. So which is going to be the right answer? Which is going to be the right answer? Total energy is minus 3.4 now. Kinetic energy will be positive, so this will be 3.4. And potential energy has to be negative, so we will be getting C, and that should be 2 times the total energy. Okay, so we will be getting option C as the right answer. Understood everybody? Yes or no? Everybody went for the ZSK match. Huh? This is so unfair, guys. This is so unfair. So now, ratio of longest wavelength corresponding to Lyman and Balmer series. When I'm talking about Lyman, okay, so the first, to the ground state, right? So the final state supposed to be ground state, which means it's supposed to be 1. And the longest wavelength you will be getting when the shortest distance, okay. So we can say that Ni must be 2. And the lambda value will be, okay, for the Lyman series, which will be coming as Rydberg constant into 1 by Ni square. Now it will be 4 minus 1 by 1. Okay, so in the Madri for Balmer, what will happen? The final one, it is nothing but the first excited state, and to get the maximum wavelength, it has to be 3. So again, you can find 1 by lambda b, which means wavelength of Balmer, which will be equal to 1 divided by 9 minus 1 divided by 4. So you can just do this and you can just find the ratio of it. Okay, so you have to find lambda L by lambda B. So this is what the equation number 1, this is what the equation number 2. To get this, you should do 2 divided by 1. Can you give me the answer for this question? Can you give me the answer for this question, everybody? Yes, it is coming as 4 by 3R. Lambda will be coming as 4, Lyman it will be 4 by 3R. Now you can find it for the Balmer. The ratio will be, as you guys mentioned, it is 5:27. Very good, very good. Okay, so the answer will be 5:27. Now let us move on to the next question. Taking the wavelength of first Balmer line, in hydrogen spectrum, which means n is equal to 3 to n is equal to 2, as 660 nanometer, the wavelength of second Balmer line will be. So again we know the first one, the wavelength we got it as 660. So 1 by 660 nanometer will be equal to the Rydberg constant into 1 by same, I mean whatever you got in the previous case you can just directly substitute. I'm just giving the steps, okay, as like it is a new fresh question, I'm just giving you the steps. So 1 divided by 9 minus 1 by 4. This is what the first case. Now second case in the wavelength that we need to find, which will be equal to r into second node. So this will be coming as 1 by, okay, so 1 by initial state will be 16 minus 2 so it will be 4. So now from this case you can just find the lambda value. Yena only one unknown da irukke. So can you just find the answer? First one you will be getting 5r by 36. Second one you will be getting 3r by 16. Okay, first one 1 by 660 nanometer. Adula vandu you will be getting 5r by 36 and idula vandu you will be getting 3r by 16. Okay, now take the ratio. R will be get cancelled. You can find this lambda value quickly. You can give me the answer. What is going to be the answer? Everybody. Yes, Hajar, very good. It will be option C. Yes, Manchu, it will be 488.9 nanometer is going to be the right answer. Very good. Yes, Durga. Yes, very good. So now can we move on to the next question? Yes, Fatima, very good. If you're ready for the next question, can you give me a fire? Breaking. I'm just playing with this. That is what. Sorry, Suresh. Okay. Now it's fine, right? Yes, thank you, Fatima. Thank you, Jia, Manju. Yes, Fatima, Samiksha, right? I'm pronouncing it correct, right? Right. Okay. So now let us move on to the next question. Let's see what is the question. This question I think we have done, correct? Yes, we have done. Can you do this question? Calculate mass number of that nucleus whose radius is half of the germanium. Okay, how we will be finding it? Calculate the mass number. So we have a relation. Okay, we have a relation R which is equal to R0 into 8 to the power 1 by 3. Okay, so in the equation use panni you can just find it. Again guys, don't forget to like the session, and also if still you are not enrolled in the RE-NEET crash course free crash course da neenga join pannalana just join. Adukku simple ore step da irukke nama description box la first link la first one. Okay, adu click panna podum, you can just access the app. All test series, assignments, leaderboard, your performance analysis, and all the sessions, adoda replay, ellame you will be get it. Okay, Hasina ma'am will be coming, this Sunday. Okay. Yes. Very good, Fatima. Very good, Preeti. Yes. So idhula pathena we know that this is what the equation. So R by 2, when R by 2 divided by R, which means I'm taking the ratios of the both the cases. So now I can say that this is going to be 8 to the power 1 by 3. This is going to be 72 the whole to the power 1 by 3. So while doing this, this R will be get cancelled. We will be getting 1 by 2 in the left hand side, and right hand side you will be getting A by 72 all to the power 1 by 3. So while we are doing this, you will be getting the answer. Okay, can we go for the next question? Yes, correct, correct. This we have done. Hey, I took the same questions. Okay, here we have the question. If a star can convert all the helium nuclei completely into oxygen, the energy released per oxygen nuclei is. So we know that to get this oxygen, we should have 4 helium, right? Okay, that is coming as nama oxygen, correct? Okay, this is what the case. Okay, so 4 helium will come together and it will give you the oxygen. So right now energy na it is nothing but delta mc square da. Correct, delta mc square da. How we will be finding delta m? So we know that here 4 helium, okay, 4 helium, and the mass of the helium is also given. So 4 into 4.0026, and mass of the oxygen nucleus is also given. So adilirundu you can just subtract and you can just get the delta m, and you need the answer in electron volt. So you can just do 931.5 mega electron volt. Even you can do with 931 mega electron volt. Don't keep the 0.5 and all. Okay, are you guys getting it? So the delta m will be 4 into 4.0026 minus 15.9994. Okay, delta m I will write here 4 into 4.0026 minus 15.9994. So you can just find delta m value. Adukapra you can just multiply it with the 931.1 mega electron volt. Yena idellame vandu AMU lata they have given. So 1 AMU is equal to, okay, the energy equivalent to 1 AMU is 931.5 da. So whatever you are getting here, other and the value into 931.5 will give you the right answer. Option Z, are you sure? I think you people are googling the answer and you are giving. How you can just do the calculation in a very short time? Answer correct da. Okay, answer is correct. 10.24 da. Okay. So how many questions we have done? Do you guys anybody is having any idea? And also how many, I mean, if you don't know the number of questions and all, but you know how many number of questions, almost the percentage. Okay, if 25 questions pannirike, and the 25 questions almost 70% of the questions I could do. So can you just give me the, I can send you a pic of my rough sheet. But I'm sure about one thing, Fatima. Usually I too have rough sheet. Adha vida better irukku. Okay, you know, my rough sheet, wherever I'm writing anything, that is the worst. Okay. Okay, so how much percentage you feel like, okay, ivlo pannirke ma'am, this much of percentage I got the right answers. So how you will, or otherwise how much, confidence in this chapter, modern physics. Mine is also worst. Then perfect. Same pinch. Okay, but nobody can beat me. That the most, okay, you can, while I'm doing also, you can see in the board na, it's and I will take a lot of space as well. That is a 97% got right. Very good guys, very good, super. So now can we go for the next question? Ready? Ready? Give me a fire if you're ready. And guys, don't forget to like the session. I want more likes. Still you people are becoming more and more confused. Okay, selfish people. You don't want to see my happiness. 85%, very good. Give chocolate to ma'am. Why Durga? Why suddenly the chocolate thing is coming? Yes, Sekar. Yes, Sanchu. Yes, Durga. Yes, Hajar. 75%. Very good, very good, very good. Okay. So now let us move on to the next question. Okay. Obtain the binding energy of nucleus. We have done, no. Oh my god, very good. So almost all the questions I think I have done. I mean, copied the same questions. But one more thing which I felt like you people, I mean, initially you people well felt like I don't remember anything and all, but Anna, right now you feel, na, okay, whatever I have studied, slowly it is coming in your mind, correct? Yes or no? Let me take the other questions. Here we have another question. When the session will end? When you people, because you pinch with Fatima ma'am. Oh, another customer. So apdina, you just tell me what are the similarities we guys had. Okay, then I'll get more chocolates, no? Okay, okay. In VLC, the same questions are from VLC. What is it? Online content. 90%. Very good. So guys, don't forget to like the session. Now we are again going for some more questions. Okay, I want all your attention here. I need all your attention. Okay. So now the question, an electron in the ground state of hydrogen atom has a ground state, okay, which means n is equal to 1, the radius is equal to 5.3 into, okay, 5.3 into 10 to the power minus 11 meter, while that of electron in the third excited state is 8.48 into 10 to the power minus 10 meter. The ratio of the de Broglie wavelength of the electron in the ground excited state. Okay, so now the thing is, like we know, nama de Broglie wavelength oda equation enna, lambda is equal to h divided by mv da, correct? H divided by mv da. So now h divided by mv sollumbodhu, I can just take it this mv from Bohr's atomic model. Okay, mvr, which is equal to nh by 2 pi. Do you guys remember this equation? Do you guys remember this equation? Yes or no? Do you guys remember this equation? So, I can find this mv. Okay, I am taking this r over here. So, I will be getting 2 pi r. Now, what I am going to do? I will be substituting here. So, I will be getting nh 2 pi r. H will be get cancelled. I will be getting 2 pi r divided by n. Till this understood, na, give me a heart. Till this, if you understood, if you are feeling confident, please let me know. Everybody, please let me know. Everybody. Very good, Manju, very good. So now, in the case I understood lambda is proportional to r by n. What is the question? The ratio of de Broglie wavelength. Okay. So now I can say that lambda 1 divided by lambda 2 will be equal to Re divided by Ne. Okay. Ne and yes. So in the excited level and yes. Okay. So this is what the N2 by R2. This is what you needed. Okay, wow. So values you have, N1, N2 you know, R1, R2 is given in the question. Can you just go for it? Can you just substitute the values? Ground level na N is equal to 1 the excited state na it will be coming as third excited state na 4 da. Okay. So N values we got it. This is coming as 1 and N2 will be coming as 4. Already this radius is given as well. Yes guys, why again so much of selfishness? You people are good. At least sometimes you can just check it, no, whether that like button is working or not. But I know you people are more lenient to this, what to say, and the dislike button is working or what. That is what you people will check. So that is the thing, that is the fact. Okay, so give me the answer for this question. Give me the answer. 5.3 into 10 to the power minus 11 divided by 8.48 into 10 to the power minus 10 into 4 by 1. This is going to be the answer. You can give me the final answer for this question. B, check again, da. Check again, not B. Guys, don't forget to like the session. And also, if still you haven't enrolled in the free RE-NEET crash course, including the test series, there are so many things were there. So you can, thank you Govind, thank you. Okay, so many things is there. So you can just enroll in it free of cost, 0 price. Nama description box la first link click panna podum. Okay, so what is the answer? I'm not getting the answer. B, how it will come? B should get 4. Check the power. One is 10 to the power minus 11 and another one is 10 to the power minus 10. Check the power of this 10 will make a kind of confusion. Very good, Durga, very good. So we will be getting option A as the answer for this question. Now let us move on to the another question. The work function of cesium and lithium metals are 1.9 and 2.5 electron volt. If we incident a light of wavelength 550 nanometer on these two metal surfaces, the photoelectric effect is possible for the case of. So how we will be finding the energy of the photon, which is nothing but hc by lambda. H value we know, c value we know, lambda value we know. So if lambda is given in nanometer, you can also go for the expression. This is given in electron volt, right? So 1240 divided by hc in electron volt. This is going to be the answer. And wavelength 550. You don't need to mark 10 to the power minus 9. We have already considered. Okay. If the wavelength is coming in terms of nanometer, na, this divided by and the value you can just add. Okay. No need to add 10 to the power minus 9. If the wavelength is given in Armstrong, na, you can go for 12400 divided by 550. Okay. So now you can just give me the answer. What will happen? What will happen? Very good, very good. Cesium is 1.9 and lithium is 2.5. So the energy what you are getting, if it is option C, lithium only, na, definitely cesium will also come, na. So option C is wrong. What is the energy you guys are getting? Let me know. C is wrong, C is wrong. How you will be, if let us say C is correct, okay, just logically you think, okay, yes, we are getting 2.25 electron volt. Very good. So this value is more than 1.9, which means cesium. This is less than 2.5, which means lithium. So lithium won't be having anything, cesium only. And logically you think da, if in the lithium only, you cannot say that because other vida less da idoda energy, cesium. Okay, so we will be getting option D as the answer for this question. Okay, done, understood. Give me a fire if you are ready for the next question. Give me a fire if you're ready for the next question. Everybody give me a fire. Okay, so yes, we are going for the next question. A light source of wavelength lambda illuminates a metal surface and electrons are ejected with a maximum kinetic energy of 2 electron volt. If the same surface is illuminated by a light source of wavelength lambda by 2, then the maximum kinetic energy. Okay, work function is given 1 electron volt. Very easy question. A light source of lambda is illuminated with a metal surface of electron. Maximum kinetic energy and the time வந்து 2 electron volt இருந்துருச்சு. அப்படினா we can say that we have the equation energy of the photon which is equal to work function plus kinetic energy da. Correct? So right now we know the maximum kinetic energy was 2 electron volt and work function was 1 electron volt. So energy of the photon we got it as 3 electron volt. Purinjida. Now what happened if the same surface, same work function, then light source of lambda by 2. Okay, then what is going to be the, which means wavelength has reduced. So what will happen to the energy? Can you just give me the answer? If wavelength has reduced, what will happen to the kinetic energy? It will increase, decrease, or remains the same? Can you give me the answer? Can you give me the answer, everybody? Everybody give me the answer. 44 likes more. Our target வந்து achieve ஆகாதுடா. Good mind people are not there. Correct. Remains the same. No, Fatima, no. Never. What will happen to the kinetic energy? Lambda reduced na, kinetic energy will increase. Yena energy vandu hc by lambda da. So lambda reduced, which means energy will increase. Correct? So I am getting here. Okay, from here I am getting hc by lambda, which is equal to 3 electron volt. So idhilirundha I can just go for this to answer. Simply I can remove. Why? Because it should increase. The energy increase aganum. It is mentioned it as 3 electron volt and lesser value, so that is not possible. Now the turn is like either 5 electron volt or let us say 6 electron volt da nama answer varaporom. So adukkaga I can do one thing. Okay, I can do one thing. I can go for second case la enna they are saying hc by lambda by 2. Okay, which is equal to work function 1 electron volt da plus nama kinetic energy for this question. Kinetic energy for this case. So now I'm just going to make some changes over here. Okay, I'm just going to make some changes here, which means 2 hc by lambda, which is equal to 1 electron plus kinetic energy. Now tell me, what is hc by lambda? 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 We already got it 3 electron volt. First case we got hc by lambda na 3 electron volt da. So 2 into 3 electron volt, which means 6 electron volt, will be equal to 1 electron volt plus kinetic energy. Now can you give me the answer for this question? Can you give me the answer for this question, everybody? Can you give me the answer? What is going to be the answer? Very good, very good. We will be getting option A, 5 electron volt as the answer for this question. Very good, very good. Super cool. Okay, now we are moving on to the another question. Okay. Yes, let us do this. Okay, a subatomic particle of mass 10 to the power minus 30 kg is moving with a velocity 2.21 into 10 to the power 6 meter per second under the matter wave consideration. The particle will behave closely. Okay, it will behave like X-rays, infrared, gamma. So this is what the question. What is given? Mass is given, velocity is given. So definitely we know the de Broglie wavelength it is nothing but h divided by mv. The h value we know 6.6 into 10 to the power minus 34 divided by mass is 10 to the power minus 30 into velocity is 2.21 into 10 to the power 6. So by doing this, you will be getting a wavelength. So on the wavelength on the which range it is coming. Okay, it is coming in X-rays or infrared or gamma or visible. That is what the question. Can you give me the answer? Can you give me the answer? H you can substitute, mass you can substitute, V you can substitute. So இன்னைக்கு வந்து நம்ம CSK is not going to perform well da. Let us see. So actually வந்து what is the wavelength you are getting? What is the wavelength you guys are getting? It is coming as 0.01 nanometer to 10, right? So which is in the range of X-rays. So option A will be the right answer. Can we go for the next question? Ready enough fire everybody? Give me a fire if you are ready. I want more fire. I want more fire. I want more hearts. So tell me, are you ready for the next question? Yes or no? Yes or no? Very good, Samiksha. Sorry, not Samisha. Very good, Govinda. Very good, Manchu. Yes, yes. I hope you guys are ready for the next question. Yes, Durga. Jehi. Yes, Govinda. Yes, Deva. Yes, Manchu. Yes, 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 yes. So, lots of hearts, lots of fire. So, now we can just go for the next question. Okay. A light wave described as like this. Okay. A metal surface of work function 2.8 electron volt. The maximum kinetic energy. This is we need to find. So kinetic energy expression is energy of the photon minus work function. Nama kinetic energy expression. Work function la confusion it is directly given in the question. Next one is what is the energy of photon? This is what? Okay. And the light photo and the light kulla irukra photon energy da nama vandu find pannanom. So idhula vandu paathena energy of photon which is nothing but h mu da. Okay. Ana vandu we know that in the mu is not given. But by seeing the equation we know that omega is given. So we know that frequency which is equal to 2 pi by omega da. So right now, sorry, omega by 2 pi, right? Omega by 2 pi da. So I'm just going to replace it. H omega divided by 2 pi. Correct? H omega divided by 2 pi. Till this understood, please give me a heart. Everybody, please give me a red heart if you understood till this. Till this, if you understood, give me a red heart. H omega by 2 pi will be the energy of photon. Now, next step is, this equation la paathena 2 omegas irukku, correct? Sin omega t, sin omega t. So idhula which omega we should choose? Eppovume indha madri question la it is asked for the maximum kinetic energy. Adukaga you should take the maximum omega. You should take the maximum omega. So you will be getting h divided by 2 pi. Omega maximum varaporadhu vandu 12 into 10 to the power 15 da. Correct? So now we will be getting the energy, and we need the energy in terms of, okay, in terms of what to say, electron volt da we need it. So I'll be going for 1.6 into 10 to the power minus 19. Got it, everybody? So H omega x, omega max. Omega max, why we are doing this? Because we need the maximum kinetic energy. To get the maximum kinetic energy, I can go for the larger value in the omega. I will be choosing the larger value of omega. Adukapram to get in electron volt. Yena, nama work function kuda electron volt la da irukke. So I'll be converting into electron volt. So I'll be getting the energy of photon. And the energy of photon kadachena, I can just subtract it from the 2.8 value. So you will be getting the answer. So approximately you will be getting 7.9 electron volt as this, as this value. Everybody got it? Yes or no? Can you give me the answer? 7.9. Everybody got it? Can you please let me know? The energy of the photon will be 7.9 electron volt, okay, and the other one which is going to be 2.8. So what is the answer? What is the answer? Option D. Very good, very good. 7.9 minus 2.8 will be giving you 5.1 as the answer. So definitely Rajkumar Master Medicos, you can just watch these lectures also, but right now nama students they are struggling da in the short time they need to cover everything. Adanala da actually we are just giving focus for this one, but definitely in the exam mudinjadukku appuram we will again go for the Master Medicos. No worries, no worries. Okay va? Fine. Okay, you can watch these lectures because idha vandu nama Master Medicos la we are going to discuss na. So don't worry about it. Ana vandu right now we should give more priority for this da. Okay. Yes. So everybody got the answer? Yes or no? Give me a fire if you got the answer. Give me a fire if you got the answer. So these are the things we have discussed till now. Okay. So now I hope you guys got a good, what to say, konjam confidence vanda adhigama irukku nenikiren. Okay, and also if you felt like okay modern physics la vanda almost all the types of questions vanda inneki we have done. Okay, so the thing is like in the chapter la irundha usually vanda same pattern of questions vanda repeat agum. So definitely what you guys can do, you can also repeat the same set of questions. You will be getting more confidence, and if you feel more confidence na, let me know through the feedback. Okay, nama comment box la I should know about it. Inneki vanda we did a lot of questions. Okay, I think we have done more than 30-35 questions. So on the questions ellame vanda you have to practice again, not the questions you are super confident. Okay, ஏனா வந்து we don't have much time, no, ஆனா வந்து concept வந்து revise பண்ணனும். And also I will share this notes, so in the session முடிஞ்சதுக்கு அப்புறம் you can see it. And also till this you guys haven't what to say joined in the what is it நம்ம re-NEET crash course la join பண்ணலனா please let me know guys. நம்ம what to say நம்ம description box பார்த்தா போதும். Okay, so let me just show you one more time. Okay, because ஏனா இது வந்து அவ்ளோ what to say, you guys have given a lot, so over student kume vanda all the benefits should get to each and every student. Adanala da we have done this, so make sure you people have joined it. And also I wanted to know how many of you have enrolled in the what to say ipo vanda channel la new ah irukke, so ma'am we just wanted to know. Okay, and the madri irundichna please let me know how many of you are enrolled in the session. I mean nama one second. Yes, let me just show you. Okay, so ipo vanda oh this won't go. Okay, so I cannot show you, but definitely da it is having a lot of efforts nala da we have made it. So guys, don't forget to join. This is a kind of what to say better thing for you people. Your betterment da nama vandu focus pannom, so please guys don't forget. Okay, so I hope you got the confidence. You guys were done a very good job. Many students has given the right answer. Lots of students has what to say very much energetic in the session. I think that is the best part happened in the session. Okay, so thank you so much da. So let us just wind up the session. We will continue with the tomorrow session. Marakama join panniko, and thank you so much. Okay, see you da, bye bye. And also let me know what is your expectation, the things about this session in the what to say nama comment box la enakku vandu paakanum. Okay, thank you da, thank you so much, bye. Thank you, bye. Yeah, I think now it is visible. So இதுதா வந்து நம்ம description box எங்கடா, yeah நம்ம description box ல first link. If you see here, you can see நம்ம first link da, and also you can just join the Telegram channel as well. ஏன்னா Telegram channel la kuda teachers வந்து personal going to connect, and today I will fix everything. ஏன் Telegram la வந்து கொஞ்சம் problems இருக்கு, so I will fix that as well. So don't forget, everyone, okay, everyone should what to say, join it. Okay, okay. Timing 10 o'clock da, 10 o'clock, no, not 10 o'clock, 11 o'clock, 11 o'clock session will start. Okay, don't forget, 11 o'clock da. You can just see நம்ம live sessions வந்து பார்த்தா போதும்டா. Okay, நம்ம live sessions ல ஒவ்வொரு செஷன்ஸுமே வந்து ஸ்கெட்யூலாக இருக்கு. You can see here. Okay, so next next upcoming days ல what are the sessions coming, அதெல்லாமே வந்து yes, நாளைக்கு வந்து நம்ம most repeated questions தான் நம்ம வந்து டிஸ்கஸ் பண்ண போறோம். And sharpa 11 o'clock க்கு வந்து we will start da. So you guys can just join this, and மறக்காம everyone should like the video. Okay, before the session most repeated questions da. So before the session I want to make sure you people have liked the session, and also correct வந்து notification you guys have to get. Okay, most important. Okay, most repeated questions da. Okay va, and the rest of the sessions also you can see it. Okay, nama where is it, okay, this sessions are over. Yes, nama 11 am க்கு வந்து my class, then you can see நம்ம Ashwati ma'am oda class irukku. Next day again we will be continuing with this. So next day I'll go for kinematics. ஏனா வந்து many students were asking about this kinematics 11th grade topics வந்து many students were asking, so I will do that as well. So thank you so much da, bye bye.